All of you. So, hello, all the dignitaries. A very good morning to all of you. So, we're continuing with our theme one intelligent systems, and this is session 4A now. This is cybersecurity for connected systems. And our session chair is Professor Sumitra Kumar Sanadhya, who is a professor in the Vadhwani School of AI and Intelligent Systems. Professor Sumitra Sanadhya is a professor in Vadhwani School of AI Intelligent Systems, WSAIS, as we call it, at IIT Kanpur. He heads the Center for Cybersecurity and Cybersecurity of Physical Systems, C3I, and is also the program director of C3I Hub, which is an organization working towards translational cybersecurity products at IIT Kanpur. He is an alumnus of IIT Delhi and holds a PhD from ISI Kolkata. His research interests include design analysis, efficient implementation of cryptographic algorithms and protocols. He leads many initiatives in these fields, including mentoring startups, running academic programs, and executing projects with many Indian government agencies and corporations. With that, I give a warm welcome to Professor Soumitra Sanadhya. I request him to come onto the stage and conduct this session.
Thank you very much, Professor Aditya. It's my pleasure to welcome you all to this first session on cybersecurity for interconnected systems. We have three speakers in this session, and the first one is Professor Deepanita Roy Chaudhary from IIT Kharagpur. She's a very well-known and a very senior expert in cybersecurity. Most of you probably already know her, but anyway, I will introduce her, and it's my privilege to introduce her to you. Professor Deepanita Roy Chaudhary received BTech and MTech degrees in computer science from the University of Calcutta in 1987 and 1989, and PhD from the Department of CSE from IIT Kharagpur in 1994. She is currently a professor in the Department of CSE at IIT Kharagpur. She has published more than 160 technical papers in international journals and conferences. Her current research interests include cryptography, VLSI design, secure embedded systems, and cellular automata. She is the recipient of INSA Young Scientist Award, Abdul Kalam Technology Innovation National Fellowships Award, and the Association of Indian Academy of Science. She is also a fellow of INAE. With that, I would like to welcome Professor Deepanita Roy Chaudhary to talk about cybersecurity challenges and countermeasures for implantable medical devices. Thank you.
Good morning, everyone. Thank you, Professor Shanadha, for the introduction. So today, I'll be talking one topic that cybersecurity challenges and countermeasure for implantable medical devices. Actually, this is in the intersection of healthcare technology, cryptography, and the safety critical systems, or we can tell some cyber physical systems, some secure cyber physical systems. So, outline of my talk. First, I'll give some introduction that what is the implantable medical devices are, and why the security is a major concern for these IMDs. Okay, then a lot of research requirement that mainly today I'll be telling that part, the research motivation, that what are the challenges and why it is so critical. And then the cybersecurity challenges in IMD environment, because there are restrictions, and why it is important, but still why not people are working. And then the security threats, that means what are the attacks or from security concerns actually. Then security goals. So what will be the environment that we have to prepare or we should provide so that we get a secure IMD. And then most of the things are future scope of work, because particularly in our country and all over world, this is a very new topic, but probably within 5 years, it will be actually coming in big shape. And then the current challenges, or actually what we should do. So as I told that I've given the recommendation. Okay. So first thing is that now what is implantable medical devices? So that in one sentence, I should tell that this is the embedded technology for human health. That actually this is I have kept in two parts. One is that left part it is miniaturized internal technology, and where actually these implantable medical devices are some we can think then some hardware equipment like some chip which is surgically placed in our human body and that replace or monitor our some physiological functions. So very simple way if I tell this is the thing. And the second part is that again we can define autonomous life management. So these devices are actually they operate and they continue to give support to our these physiological functionalities. So this enhancing the health outcomes to automated therapeutic intervention. So not only it is placed but actually to continue, and here actually the security part comes in picture. So slowly I'll be coming there. So very simple way. So this is the thing. And now see, there are many. Just I have given very, which is very popular. But actually nowadays there are many such IMDs from small chips to big one and with very important functionalities that is there. These are actually which are very popular that we have given. So this is some deep brain neurostimulators. Actually, this stimulates and even that very that important things that is our normally nowadays we see the depression. So actually this stimulates and it works very well for the automatically it stimulates whenever required and it control the depression. And then many others that diseases that important diseases it actually that epilepsy and this thing it works very well. But one thing, okay, later. And these cochlear implants, this is actually the auditory of this, the ear, that again it is a stimulation, and whenever required, automatically that it will stimulates. And these are all automated, not needed every day to monitor that thing. But some monitoring is required, and there the security is there. So this is some gastric stimulators, and this is most important thing. And in our country also, even last almost 8 to 10 years, that many hospitals they are using these that cardiovascular defibrillators. We just immediately we can think this is as a like the alternate of pacemakers, but it has many other functionalities and there are variants. If we go some hospital, that good hospitals website, we will be seeing that what are the different variants like Peerless Kolkata. They're using so many variants of this thing, starting from that even the price from 20,000 to 6 lakhs, like that. So they're almost all are using, particularly in India. It is actually this is very important thing, and because it is replaces some of the functions of the pacemakers. Similarly, foot drop implants, actually this is something, some stimulus for our muscles. And then insulin pump, this is another thing. Almost every people are using, and one very good thing is that in our country that actually is in very cheap, the chips or IMDs are available for this. So there are many such. These are very popular, but there are nowadays that actually the chips are implanted. That's as I already mentioned, surgically placed, and they are this thing. Now the question is, okay, then where is the security is coming? Security is coming. So before that, just we see that quickly. We see that what is the picture worldwide. So this is actually a breakthrough. So only 1 year this left hand side that this is the 1 year's statistics, and we are seeing that actually in US that it is mostly there it is used, and from 96 million to double that type of things are there. And even in other regions also, it is slowly it is growing. So it is nowadays, now it is not experiment. Now it is actually established and all over world that people are doing. Now, evolution is quickly, if I tell that 1958, the first pacemaker, again, this is the, what actually nowadays the implantable cardioverter defibrillator I told is ICD nowadays. Now this is earlier, it is the original, it is started with this thing, that 1950 first pacemaker, but that time it is only standalone mode, it is only placed and then used to. So that time surgery was required, like our conventional pacemakers. Now this 1970, that actually telemetry added. So there only that one-way communication that is started. So this is actually the breakthrough comes from 1970. Then 1999, that again that some, this is the, that government has given some bandwidth that can be used for this communication, and actually the both way communication started. And now 2006, there are many ways it has come and it is actually continuing. So slowly I'll try to give the picture. So where is the, it is now up to this, there is no security things are there. So just I give one example, that communication environment. So first thing is like pacemaker or ICD, that defibrillator, what I was telling, that type of thing. And see, it's a programmer, or normally we call in technical term is device programmer. Just we think this is a computer. Okay. And this is something. And here actually the doctors and the assistants, or these are authorized. So they are here. So this is a very simple model. All over world people are doing that thing. So here they are communicating, because we get now this is a both-way communication. But always we'll try that, since these pacemakers, we understand that whatever these IMDs are, they are resource constrained because they are implanted on our body. So they have battery powered, and not that these batteries are rechargeable, and they have very less memory. Computing facility is also very less, not very small processors are there, not our big one thing. So these communication, these between these two, this will be very, we try to make it the restricted, but still we have to do all the things. So the here this tag to this device programmer has a lot of responsibilities. So here we can use some good computers, some this thing, and a lot of and these doctors, that actually they will be mainly, see this internet is here. So here we can do, and most of the things we'll be using here, and then the access or the interaction will be very limited, so that the it is that security part or even other difficulties that may not arise. So first thing is that where the security. So one small thing is that these are monitored from outside. So that is the small thing that that is the very important now. So since they are monitored from outside, whether it is a doctor or that other medical assistance, so since it is a remotely monitored, so not all people will be the good people and they will be doing the good things. So many times that it is this is the first thing, that people can do some harm. That means what is not required, that is they may actually do the things. And now this what they can do which is not required, that list is growing day by day. And then security concerns are there. So interaction, our aim is that user-computer interaction. So most of the processing related security may be performed on the computer only. And computer IMD interaction, only the sensitive operation associate the IMD, that only will be doing here. This is the overall philosophy all over world that we are doing this research. This is the model. Okay. So this is the model. So now that this wireless access, a threat surface for implantable device. So from where the security is coming? So see, that possible security breach can lead to vulnerable situations. So modify legitimate IMD operations, mainly these three are there. So what are the IMD operations? Because doctor has to tell that whether I have to give a small pressure to the ICD. Okay, now if in between this is some IMD operations, now it is actually the all commands are there. So if I just change the commands, say I have to say increase the pressure. Instead, if I give that only one parameter, that if I make it that decrease the pressure, then it's actually a life threat. So, and the reverse also. This is one example. And there are lot of this type of operations, and it varies from IMD to IMD because functionalities are different. Then misuse patient-specific private treatment logs. And then this is one of the things that normally now in many other areas also we are doing the theft of that patient data. But here it is very critical in that sense that if we have access on that patient data and if we change, then actually say the doctor will get the wrong logs, wrong informations, and based on that the doctor will take the wrong decision. So this is also very important. And another, the deplete battery power unnecessarily. This is the simplest way that attacker can do. So since it is a non-rechargeable, normally the 6 to 10 years that type of support it has, that battery works. And now if unnecessarily we just try to access that thing, so nothing, probably it is very much secured, we cannot do anything. But every time that the IMDs have to work, and so what they will be doing, that battery will actually deplete, so battery will be rich. So this is the most we should tell that innocent but dangerous, because then again surgery is needed, that type of thing. So the what is now we are calling embedded system security. Now we understand that these IMDs that are actually placed on the body, like we can think this is the embedded systems, and or even ASIC we can take. So these are the ASIC for secure IMD, that should be the goal, because nowadays the IMDs are available but no security is there. Till date, that no security is there. So identify the relevant attacks and the analysis of embedded system security. Because we understand the functionality of IMDs are different, so obviously attacks will be different. And so everywhere that we have to identify the attacks. Then design and implement lightweight crypto primitives for encryption and authentication. So all over world, that very few groups they are working, but what we and other group also that we are doing. So if we can apply the cryptographic protocols or primitives, that should be lightweight, because for the resource constraint things, because at least some part that ICD should be involved. So even the device programmer, the tier 2, so they do the most of the computing, but I have to do that thing. So that's why this lightweight crypto primitives to identify and to this is one of the challenge here. And then design FPGA or ASIC prototype of secure IMD. As already I mentioned, many IMDs are available, but till date, to the best of our knowledge, that not security is there. But all over world, that people are actually trying to do that thing. I'll tell here some of the things that why it is not, etc. So solution, very roughly I will tell. Now slowly we'll be going in slightly details that with continuous authentication, it would be very nice, because at least if we assume that the doctor has some password, and then this is some authentication is every time to access, at least some authentication is required. So this authentication is very important here. Then proximity-based access control, continuous authentication, and then lightweight access control protocol, or design of lightweight authenticated encryption. So authentication encryption, because what we have identified when we have seen the ICD commands, then few commands are actually only encryption is required. For few comments means the attacks, if we consider, only authentication is all. But for some of them, both authentication and encryption. So whether the lightweight HTML can be good, because that we have to every time we have to remember that here the environment is totally different, because here we have not much processing power. So with how far we can do with this, and then the ASIC design or FPGA, whatever we take. So as I told, the research motivation, because here a lot of things, people have just started, only few groups they are working, but within already in US this type of attack is started, and so we must be very careful about this. So the widespread global reliance on IMDs and the immense lack of security measure for the IMD environment, and the vulnerable wireless telemetry over the network and radio frequency communication. One of the most active IMD is implantable cardioverter defibrillator, as already I mentioned. If you just give a survey, you will be seeing in India also that most of the good nursing homes or hospitals, they are actually variants of ICDs they are using, and illegitimate access to sensitive configurations of ICD patients' private health data. Just the previous slide I told. There are many more. Just very abstract way I told that why it is necessary, and where many areas actually, this is the interdisciplinary area. So even later I'll be telling that even chemistry, etc., that is also there, will be coming slowly. So security challenges in medical implants, there are many, but if the most important two things, if I note, that one is for that resource constraints, already I told, is a very limited CPU power, memory, and battery life is 7 to 10 years, non-rechargeable. Security must not compromise primary life-saving function. Because just if I give a different command, so it will be life-threatening. That I have to increase the pressure. If I just in place I tell that, okay, decrease the pressure, then it's a, and similarly all such comments are there. Then so this is these are actual challenges, the resource constraint environment, to embed the security. Then communication constraints. So wireless communication drains battery and emits radiation, and risk of RF exposure to nearby issues. Obviously, wireless communication, actually this is a breakthrough, and particularly this type of application. But again, parallelly, that this type of disadvantages are there, particularly here. And then weak body-induced fading channels limit performance, or traditional wireless security methods are inefficient because for the above restrictions. So there are many more, at least these two broad things I try to know. And then quickly we see that what type of attacks. This is overall, but obviously this IMD to IMD, it will change the thing, which one will be prominent for. So data manipulation attack, resource depletion attack, that communication attack. Under communication attack, that normal cryptography security, that you know, that this type of replay attack, denial of service attack, man in the middle attack, and firmware injection attack, that is actually very critical here. So these are some of the attacks with cyber security threats. So data manipulation attack, that actually from the name itself we understand that the device programmer and the ICD, as already I mentioned. So this we can think a proper computer, that most of the tasks we want to do there, we have a good server. And these IMDs are, this is the thing. So if it is an attacker, so it will be data manipulation attack, that it will actually try to, because it's a wireless communication, so normal, our common wireless attacks that we consider in cryptography, that type of things, it will be it will be there. So this is some malicious external device. A resource depletion attack, already I mentioned, the battery will deplete if more, not actually even some unnecessary communication we are doing, just we are trying to access. Nothing we can do, but actually every time you have to check whether it is a legitimate user or not, authorized user, and for that some battery will go down. So then the eavesdropping attack, and the denial of service attack, the normal our communication attack. that external product and see this external programmer and this IMD, actually this eavesdropping will be there. That means it will try to uh, uh, put the attack here, normal things, denial of service. And but here also denial of service is again that it will also affect the battery. Now, replay attack, that earlier if normally the protocols use some nonce or some ID. So if some previously uh, used some parameter, if they want to again reuse the replay, we know. And then again man in the middle attack. So actually the when the data is communicating, if we can want to change that thing, so it will be the this type of attacks. This is actually very, very important thing, that firmware injection attack. So actually we can think this is a software attack like that. So but it is very, nowadays this becomes a very crucial thing, that counterfeit software. So they are actually changing the, because for IMDs there are, for we understand for this is for say ICD or say some insulin pump, there are actually some what are the comments, what are the actual commands that will be there. If people change that thing, it is the same, some device programmer. So it will change and give that thing, then it will be actually a security thing and it will not work. So nowadays people are actually working here. So now see that as already I mentioned, particularly our country and others also, that ICT is mostly used, and there were variants of ICTs, different functionalities. And so there are components that like more or less these are the pulse generator and the electrodes, actually the connectors are there. So therapy are quickly giving example that say anti-tachycardia pacing to correct fast rhythms, ATP. And defibrillation is deliver a high energy shock. And then bradycardia pacing is maintain heart rate when it becomes too slow. And cardioversion, lower energy shock to restore normal rhythm. So normally commands are actually made on these four things. There are many other small, these are the broad force. Now we understand that if any one of these things, if we change, and then it will be actually in danger for or it is life threatening for the patient. So these are the things. And okay, these are already I mentioned that communication thing, security gaps in ICD communication. So already these are the mentioned. So research requirement, this is very new, but lot of research is required to identify confidentiality and integrity requirements for functional model based ICD communication. And from ICD I'm telling, but is actually number of IMDs are there. So for everyone, there will be actually separate research will be there, because functionalities are different. So commands are also obviously different, attacks will be different, countermeasure will be different. To design a lightweight authentication scheme tailored for secure IMD device. So here, one thing is that whether cryptographic primitives, lightweight cryptographic primitives that we can use, identify the relevant cyber attacks for a particular IMD. As I already told, IMD to IMDT will vary. And then to mitigate identified cyber attacks. Overall, these are the overall things. If we work any one of these bullet, actually that will be a research. So these are the protocol for secure ICDs, mainly that some optimized data transmission, because always we remember that this is a resource constraint. We don't have enough memory in the ICD. So actually protocol also we have to select in proper way that it will be there. Then key management, because normally the doctor that who is the authorized doctor, the doctor has some ID, and there are some dynamic, that is some keys generated from that ID, and dynamic key. So there are two keys. One is master key, one is session key, and session key is normally changing. So this key management is one of the thing, because if somehow the attacker or the mischiever, they get the access of the key, any session key also, then it will be actually a problem. And then lightweight encryption scheme, lightweight authentication scheme. So only on ICD we started working on last 6 to 7 years. We are working in our group, And normally we do crypto and cryptographic research and VLSI also. So here, this is one application area we can think as a cyber physical systems. We worked on this ICD, and recently we have published. This is one paper is available where actually we have, other than key management is again separate thing that we have actually tried to give this thing. Okay, and like quickly, this is the this can be a data transmission structure. Even we can think, this is just we have taken, like you see that how small it is, only the 128 bit, but you may try for this thing. Just I'm telling that where the scopes are there. Then again, the secure identification and cross-clinic accessibility. So normally all over world that the people are doing, so they're taking that authorized doctor, they have some password, what is actually from there the master key can be generated. So in our country, the National Medical Register, they give a 32-bit numbers to all registered doctors. So now currently people are using that thing. We have also worked on that. We have taken that thing, and the ICD itself holds a unique identifier. And because every ICD, like our network, computer network, it has its own ID. Similarly, that all ICDs have some unique number, and that it ensures traceability and trust in communication between these. So normally, this is the secure medical practitioner. And this cross-clinic accessibility, this is again nowadays is very, very important, because normally this is fixed environment. Say here in Kanpur, that one doctor is actually allotted there. But if suddenly, if the patient is moved to other, even in our country, other city, then actually who will be doing the thing? Who will be working? So that's why now this cross-clinic accessibility, that is also, so that other doctor can actually handle. Otherwise, only the authorized doctor in Kanpur, only he or she will be responsible for this. So this is again another research that, and people are trying to embed this thing. So there are very small issues, but very, very important, because this is very common that patient will be moving to some other city or some other country. So this is overall, just I am trying to give just how that device programmer and ICD, that communication is very crucial, because otherwise device programmer to the medical practitioner, that is actually computer to computer, that all of we know. So here actually we have tried that to go that some random nonce, and always we have to always what we have tried that to only 128-bit format, and then but what is essential, what data are essential, that will be. So this is a raw data or instruction. So this is the one thing, that data manipulation attack, what people will try to access this part. Then it is encrypted, and data instruction. Actually, it depends on command to command. And this type of this encrypted, non-decrypted. So this is one. Actually, there are people are working, and we may give that thing. So for security, mainly the confidentiality and authentication that is required. So at least these two we have identified, and we are trying to use that thing. Key management we have not yet done, but again, it is very, very important. We are working on that. So some master key, and there actually you have to incorporate, so that other registered doctor can also do that thing. And the issues are there, and always the lightweight thing. Always we remember, because we have that also we have tried. Actually, now we are trying what is conventional or standard in our cryptographic protocols, cryptographic primitives. That lightweight thing we try to do that thing. So, okay, why authentication encryption? We understand this is one of the attack. We have shown that how actually people are just data, they are manipulating only few bits if they are changed, and then actually it is giving some life-threatening comments for them. Again, replay attack and these things. So I quickly come to the very important thing. So there are future scopes are there already I mentioned, but what actually current challenges I have identified mainly two. So one is that prototype development for secure RMD, because now this is a hardware chip, but till date, at what we have surveyed and all over world, that there is no security component there. what I was telling, that even chemistry, that interdisciplinary thing is there. This biocompatibility and durability, not our concern at this stage, is very, very important, because that material should be such that it should not hamper, or it should not be some problem that non-toxic inside the body. So again, many people are working here. This is pure chemistry people, they are doing here, but they are giving that thing. So these are the things. So we think that even from engineering concept, that these are our concern. So immediately what we can do, that separately there's so many things, together how can we integrate and we can do the design. This is one. And then next one is that this is one of the things, because recently I attended in France that conference. So what is that? If there is no regulation, even all over world, now all people are trying to do that thing. That one example I'm giving, that if we buy, we cannot directly buy that some registered doctor, they will buy some IMD. So actually the vendors are not giving any information. That is the most dangerous thing. So they are not giving, because till date, none of the countries is actually these ethical things are actually there. So legal and ethical responsibility. So nothing is there. So what we saw that in Europe, actually from 2010, they started that thing, and currently it is actually a big group. Even many cryptographers, actually they are the part, many senior cryptographers are actually, they are coming to law, the cryptography law, because this is, and since it is actually life-threatening thing. So on 2017 only, 10 they have started, 17 only they used comprehensive software cybersecurity obligations, and this is 2024, that some Cyber Resilience Act, and that mandates secure by design development. Means they have to tell that it should be transparent to the patient party also. Okay, so these regulations are there. And USA again, they have the different rules, that FDA, and is very big, and now, but they are again very big group, that all medical practitioners, the doctors, and particularly cryptographers, they're doing. So in Japan, they have mandates of this thing. India, as of late 2024, what we have surveyed, that does not have a specific dedicated cyber security regulation. For only now, recently they joined IMDRF as an affiliate member, again this thing. So India is rapidly developing in digital healthcare sector, increasing the need for robust medical device cyber security regulations. So since other countries, they are actually the big group, and they have separate research they are doing. So I think that this is very, very essential in our country, at least to start with the thing, because we understand that particularly the vendors, they don't have any responsibilities. They are not giving anything. So even what is the material, for somebody it may not work well. So that, and there are many such issues. If it is not transparent, that what are the circuits, how do I incorporate the security part also, if they don't give us the thing. Even the Boston, one is the very well known, and this thing, that they Boston ICDs, that conference, they have in India, that near Delhi, their own branches there. When we contacted, they told, no, we cannot give anything. So this is the status. So okay, now time is not there, there are many issues. So at least I start to tell that what is a very, very important. Okay, thank you for your attention.
Thank you very much. You need computer connectivity program, maybe once in 6 months for 5 years. And that also application playing either on my computer or my.
Yes.
I don't need to learn. Actually, these so-called devices, medical devices, they don't have to be connected to the internet at all. You don't need, and because you don't need, so actually your cyber security requirement
is not even 0.1% of what we need for my computer, for my power grid, for my airline security, airlines reservation, for my banks. So in what way you are worried about it separately, I'm going to tell you. In my mind, you don't need at all for the medical devices because the requirement is only 5 minutes, and for that 5 minutes for 6 months, and not for that also, I don't need internet connectivity.
Okay, so first thing is that since you are user, you know, but this 5 minutes only 5 seconds is enough for the attacker. And another thing is that since you are connecting from your mobile and computer, that itself is vulnerable. That is in internet. That is in the internet. Yes, that is so. It is that. Yes, that is normal conventional communication. But for this thing, in this environment, how it is coming into picture, that is the body. That thing is.
Thank you very much.
Thank you.
I think in the interest of time, we'll move on. I request Professor Soumitra to present a memento to Professor Deepanvita Roy Chaudhary. Switch on the lights. और पीछे आप उसको ऑफ कर दीजिए उसको. Just a second.
Yeah, no.
In time.
Thank you very much, Professor Deepanvita Roy Chaudhary. We would like to move to the second talk now. After an academic talk, we are here to listen to Ms. Kamini Malhotra from SAG, the Scientific Analysis Group of DRDO, where she heads the evaluation group. Ms. Kamini Malhotra is a leader in research and development in network security assurance and cryptographic module validation in DRDO. She has joined DRDO in 1992 after completing electronics fellowship course from DIAT, Pune. She is a postgraduate in electronics from University of Delhi. She has contributed in numerous R&D projects in the domain of speech cryptanalysis, AI, and network security, serving both as a team member as well as a project director. Under her leadership, several cybersecurity technologies have been successfully developed and deployed across the armed forces and DRDO establishments. She is a recipient of DRDO Team Award for Strategic Contribution. Her current research interests include security assessment of cloud and software-defined networks, IoT network security, policy compliance, and formal verification. She has also authored several policy and guideline documents on securing WAN, cloud, SDN, and IoT networks. And today, she is with us to talk about policy and verification in multi-domain connected systems. I welcome Ms. Kamini Malhotra from SAG DRDO.
Thank you, Professor Soumitra, for that introduction. And thank you, INAE, for letting me step in for my director, who was initially scheduled to give this talk. And it is indeed a privilege for me to be talking in front of the eminence of Dr. Somnath, Dr. Patil, and Dr. P.S. Goyal, and also all the youngsters who are present here, whom I think I'll be able to enthuse on the points that I have thought, and I want to share with you that the directions that we may go in the area of multi-domain connected systems. So this would be the flow, and since I will be talking about the policy and verification in multi-domain connected network scenarios, I will just share with the youngsters who would really need to know at what we actually mean by policy, what are the multi-domain scenarios, and the two that I'm targeting are the smart city and the Internet of Battlefield of Things, but at a very high level. I'm not going to the depth of the techniques, But at a very high level, the kind of policies that we need to have, some are already there, and what we need to have so that to go in the future directions. I'll also discuss upon the friction that lies in the multi-domain scenarios, and the point of the highlight of points that I want to discuss in my talk are primarily on the data provenance, the microsegmentation, and the edge computing aspects, which have been touched upon yesterday also, but in the context of policies and verification, wherein fits in, and the work that we are required to do in future. And of course, the homework that I was given. So the homework slide is also there. I hope the INA would be happy. So what is a policy? It is a set of rules that define the desired behavior. The desired behavior is what is dictated by the management, what is mandated by the management of the interconnected devices, how they have to be interconnected, how the user needs to interface with them, how the applications need to reside, how the applications need to behave, and how the data flows have to happen. So the policies are the intent, and they are the ones which govern a connected system. They serve, and why they are there, of course, we all know that they serve to enforce consistency, security, operational efficiency, and the entire network. Today we talk about how to enforce the zero trust, and the zero trust has to be there, starting from the data source, the data contents, the devices which process the data, the applications again which process the data, and then they give us some outputs, and the communications, because ultimately in connected scenario, they'll be communicated through some ways. So policies are the one which completely govern the entire thing. We all know about, and most of you have read about, primarily the access control policies, which define who and what can access a resource, who and what can, how the data has to be accessed, how the applications have to be accessed. The humans, both for the humans and for the machines. We have our passwords, we have our PINs, the OTPs coming in. And at a higher level, we know, we can talk about the role-based access control, we can talk about the attribute-based role control. So access control policies have been widely studied, implemented in different kind of scenarios. Then policies are there in place for the configurations, which is the most vital part in a connected system are the configurations. That is the point where a malicious entity comes into your network if you're not configured properly. So configurations are with respect to your application layer protocols, your transport layer protocols. So the policies with respect to configurations depend upon the use case where you are putting your systems, and they are the policies of real critical importance. Then how the data flow has to take place. The data can have different sensitivity, how the networking has to do, whether you're using a wireless, you have to use a Wi-Fi, you have to use a LoRa, you have to use a cellular, or you have to use Ethernet or a fiber or what. So all these kind of networking technologies also are a part of it. Then the policies are what is a normal behavior, how the system has to behave if there is a degraded. So we have to put in, the policies tell us what preventive controls we have to put in. They tell us what reactive controls we have to put in. So starting from the management intent, the policies or the guidelines, they tell us what are the controls that we need to put in such connected system so that the system is operational and the system is secure. Ultimately, the aim is to prevent data breaches and to prevent data leaks and to enforce the zero trust on data source, data contents, applications, and devices. Now, what do I mean by multi-domain? So multi-domain refers to integration and operations of different kinds of systems, technologies, missions across multiple operations, environments, or domains. And each of these domains will have its own characteristics, its own constraints, it has its own trust requirements, and it may also have different authorities. Maybe in a big system, say for example, like a smart city, the municipal corporation is maybe interacting with the police. So there are different regulations. Then again, there are different technologies in place. So a multi-domain refers to different entities in the entire domain. So domain is what is decided by us. The users are the ones who will decide what the domain is. So domain itself is dynamic. Domain is not a static identity. So the whole scenario is very dynamic. Data and decisions must flow securely and reliably across these domains, and each domain will have its own risk. So that is, they will have their own attack surface. So you need to put in controls for that attack surface, and when they integrate, they give rise to a new attack surface. So what is it that that can make such a heterogeneous multi-domain environment work is the policies. The policies, and the second part is the verification. Now verification part is what my lab does. So I come from the area of verification. So policies have to respect each other's domain also. They cannot work in isolation. They have to ensure interoperability without compromising security. They need to maintain consistent enforcement across all domains and function even in the degraded environment. So the main thing is, it is the policies which govern it. So just to dive a little bit deeper is like, in generally, if we, in the context of defense or in context of critical infrastructure, the major domains would be, there would be a cyber domain. And the cyber domain, of course, the IT systems, the networks, the servers, the security policies, which focus on data, of course, and the primary intent is the confidentiality, integrity, and availability. Then there can be an operational domain also, like in terms of the industrial control systems or the SCADA systems, the power grid, the water treatment plants. And of course, a very important part is the communication domain, which can well range from the tactical radios to satellite links to cellulars or different kind of Wi-Fi technologies, which have their own constraints on bandwidth, and they have every technique will have different way of providing the security. So that will be different. Then in these multi-domain scenarios, a lot of it is like on the cloud. So cloud and edge have become an important part of multi-domain scenarios. IoT and embedded systems, again, are a part of these. And a very critical and crucial part is the human. So this is generally a scenario, and so just projecting the scenario onto a smart city kind of a use case, we would have to do a transportation will be one domain, a smart mobility will be, then energy and utilities, water and environment management. So while I'm speaking each of them, please go and connect back to, they are under different regulatory authority, they'll have their own processes. So now they all have to interoperate, and they have their own regulations, and they all have to interoperate, and each of them will be using a separate set of technology. So their cyber domain will be different, their network domain will be different. So all them have to interoperate now. So we can go on, and we can go, this is just first level of granularity. We can go we can dive a little bit down, and we have to go to the other layers which are important. Now coming to this Internet of Battlefield of Things, this picture was, a similar picture was flashed yesterday also, wherein, of course, you'll have a command center. You may have soldiers which are also connected. They are wearing some wearable devices, and artillery which is maybe, again, communicating and networked. So this scenario, which is geographically in a very different kind of environments, so they pose different kind of pictures. So if just talking a little about the IOBTs, the network and the cyber domains are very crucial in IOBTs. The data security domains are very crucial, like the data could be in some domain, it could be unclassified, and in some domain it could be confidential. And there could be, in sometimes, different countries also collaborating in these domains. So they also part, and their regulations will be different from our regulations. And similar to analogous to the data security, in a military parlance, we can have privacy concerns in the smart city, so that they also have to be taken into account. Then, of course, the computing domain, the application domain, we can have a combat domain. So these domains will be dictated by us, depending upon how we want to configure our multiple domain scenario. So mission priorities and constraints. Now the important part is that the mission priorities and constraints may change and the rules have to change on the fly. But again, we have to be secure. And a system that spans several of these domains may be there. And so then just to highlight this, I just put in a sketch here. And it could be like one segment could be having sensors, it could be having drones, vehicles, and that is having 5G and maybe LoRa, and some radios and unclassified data. And in other segment, the segment 2 may be having some artillery, there may be some 2 mission sub-centers there which are connected through 5G, Wi-Fi, fiber, it may be having classified data. And there are multiple of such segments which different kind of mission requirements. And then there is a central command and control cloud which is dictating. But what may happen is that one of the links may go down. Of course, there are redundant links given, but it may so happen that on the fly, a decision has to be taken, now what a segment 1 has to do. So in that case of scenarios, what is required to be done and how we can enforce our policies. I'm coming not only with respect to the operationalization, of course. Edge has been very widely used and it is coming up as a big technology for operationalizing such scenarios. But I have to talk in terms of policy enforcement and policy verification. So now coming to what the multi-domain friction is, there are challenges at the boundaries of these segments. If say, for example, this is just one few things that came to my mind. So this nothing exhaustive, it's a very, very top layer. How does a drone edge AI access satellite intelligence classified above it domains? Now, who takes the decision there? And it has to be done in a mission board. How do coalition partners share data without violating national policies? How do you verify that a field sensor hasn't been tampered with before trusting its data? So a lot of these technologies are put in place. But in a big scenario, how do you ensure that this policy is being verified? So to do that, enforcement is there and that verification is there. How do we do? So the interdomain policies we see are not smooth and they have to be smoothened out in the multi-domain scenarios. And maybe the policies are the glue and they are the lubricant. So the policies have to be very thoughtfully formulated, very thoughtfully enforced and verified. So there are a lot of standards which are available for such environments, like for IoT 27400 is available. For WAN, basically they are on a WAN kind of a fabric. So there are guidelines 27002 is available. SAG itself has a document on guidelines for network security for WAN, and we are about to be releasing one on IoTs. So these things are there and controls are in place. But there are some points that I would want, these guidelines don't tell what exact technology has to go in. They just tell a high level intent that yes, access control has to be there. Now what exactly has to be there it depends on the user who's putting up the network. So with my experience, I feel some of the technology which can be there for policy enforcement, with respect to policy enforcement. So those are 3 points for data provenance, microsegmentation, and edge computing. So coming to what data provenance is, it is a record of where data came from, how it was generated, and during its journey from different nodes to its final destination node, how it has got transformed, where it has moved, whom it has interacted with across its life cycle. And this becomes very important in a multi-domain scenario. So this tracks the origin, the movement, and the transformation. Why this required is, so in my terms, it is required for policy verification. So it supports policy decisions and it is critical for auditability. So policies on data provenance for trust on data and who has handled it, so they should be a part of the policies. Provenance techniques, a lot of provenance techniques are available. So like we have security audit logs, we have Merkle tree hashing, blockchains, of course. Blockchain is a big contender for in an IoT enabled, but like blockchains are really computationally very heavy, and how but people are still researching in then IoT scenarios how we can use blockchain for data provenance. So that those are existing. But my point is that maybe something more intrinsic is there. The data is traveling various paths. So these are my thoughts that we need something more intrinsic and each packet to tell its own story. We may need to put in something at the networking part of it. Say, for example, when we are communicating the data on wireless. So there's something maybe there or some other technique may be there but the data packet, each packet of data which traverses these multi-domain scenarios, it has to tell its own story where it comes from. So with respect to that, we have a lot of, this is also an area of research which is going on. At SAG, we have collaborated with IIT Delhi and we have come up with some way wherein we used a part of the payload in Wi-Fi and LoRa where we can put in at every hop, some information is put in about where the data is coming from. And finally, we were able to trace it. But that is only at a research stage. We need some production kind of scenarios where we can give it in such a heterogeneous and a very insecure type of environments. We need some techniques, but at the policy level, it has to be there. Some data provenance has to be there. So I would say maybe something in the standard itself, it has to be there. Another technique is the microsegmentation. Again, microsegmentation is the logical isolation of systems, workloads, and data flows. And it is primarily done to contain an infection. If there is an infection, so you're able to contain it in a small part. But I want to use it for policy. As a policy, the microsegmentation has to be there, and it has to be there at the workload levels. And with virtualization coming in, I think it is not difficult to do it. So this is my second recommendation is with respect to the microsegmentation within the segments. But our problem is the segments are not well defined. How do we define the microsegments? So for that, we will require to go in for some context-aware AI-driven microsegmentation at the edge. So these are it's still an area of research, and we have still not started working on it per se. But yes, this is what I feel should be there. Now, with respect to policy enforcement, how these policies need to be enforced. Of course, we can formulate policies on data provenance. We can formulate policies with respect to microsegmentations. But ultimately, in a big scenario, we need to enforce these policies. And so the current limitations may be that static policies fail in dynamic or contested environments. Centralized enforcement creates single point of failure. The policy conflicts across layers and domains. There are policy conflicts along layers and domains, and it is a very, very, very critical part of it. In fact, we at SAG have done it at a very low level of finding out the conflicts in firewalls. So our organizational networks, everyone has a firewall. So firewalls are pretty much starting in a way, but even we found out that there are a lot of conflicts in the rules that you set, and nobody checks it. And the firewalls don't give you a provision of checking those rules. So at SAG, we have developed a software based on formal methods where we can do this policy conflict checks on the firewalls, which can be, they are generally at the peripheries of a part or a sub-network of the complete organizational network. So that itself was a difficult task, and we have put it in our network. So we have deployed it. That formally doing it was a difficult task. Now think of it doing it in a segment which is dynamic, and we want to do it at the edge. So that is what at least we should aim for, a kind of a formal verification of conflicts, that conflicts don't happen. And since the input will be coming from different domains, and when you change policies in one domain, it actually hits the entire domain, and it gives rise to a lot of hidden paths which also need to be found out formally, which itself is a huge order. So that is the direction that we should be going in. And then, of course, we need to have, as far as the current is concerned, the policy effectiveness, whether the policies are effective or not, that is the verification part of it. So there's a very limited visibility if we are going to talk in a centralized kind of a scenario. So edge computing is what is being talked about today. So I'm talking about edge computing for policy enforcement also, so that there is cross-domain consistency, autonomous decision making. Yeah, so yesterday also we talked about the edge has to be autonomous. The edge has to be context aware. So they are just one sentences, but I think there is a lot of work behind each sentence. And then we have to talk about real-time verification and adaptability. So these are just some, what are the strengths and what are the cons of the centralized and distributed policy enforcement. What we actually need to have is a hybrid policy enforcement where, so this is just my thoughts. It's not a very, something that I've put in a lot of my mind on the design. So there will be a lot of if and whys in it. But so there could be a cloud, which is actually the main brain of the policies. And then there are some federated edges and which are the regional policy decision points where the provenance can also happen. They can look into the provenance aspect of it, then aggregate or any reconciliation that has to be done. And we get down to the level of some local edges where using some where there have to be some micro segments there, which are controlled by some SDNs or some firewall agents. And these are being fed by, not by the radios and the IoTs that I have shown. Mainly, they are being fed by the different segments. And the segments are the ones which will have these different components. So maybe a hierarchical approach to policy enforcement with the edge being context aware, with the edge being autonomous, so that it is able to take some decisions on its own, and a lot of AI to be implemented in there with care, with caution, as was brought about yesterday. So maybe that is a scenario we should be moving towards. So with that, this is my homework slide. So that is towards autonomous, verifiable policy formulation and enforcement in multi-domain connected systems. So data provenance as policy, of course, we will put it in our document. So, or if it becomes a part of the standard, it would be good. Then combining edge and microsegmentation for hybrid policy enforcement, AIML-based context-aware policy adaptation and validation, and formal models and formal verification of policies. It's a lot of area of research. It is a difficult area and people generally don't get enthused into. It becomes difficult for us to even collaborate with academic institutes. So we tried to do it with IT Delhi, but we could not do it. So we did it with IT Bhubaneswar. Somewhat we were successful. Then I have a small team which works on this. So I think if I can enthuse some people here, so IT Kanpur, I think is the right place I have come to maybe enthuse people work in this area. So that these multi-domain scenarios, today we are very piecemeal, like few solutions, like yesterday we talked about Wi-Fi, we talked about cellular, but they are only thinking about the integration part of it. The policies part of it, I think nobody even thinks at the stage of while you are developing a technique. So I think if we have techniques and the techniques as to how we can do it formally, then maybe perhaps they'll start to the standards, or the people who are doing the baseline network, the baseline technology components, maybe they'll start to think about the policies also. So that is what my thoughts are, and thank you so much.
Yeah, there's one question. Yeah, okay, thank you.
Yes, sir.
Very nicely.
Yeah.
I should compliment that. But one point is that recommendation or there's a policy.
Yeah.
They are two different things.
Agreed, sir.
Policy binds you,
Yes, sir.
whereas recommendation doesn't bind you.
Agreed.
So, for example, in DRDO, we have a policy that any software that is put into the system goes through a review by the SCG certification.
Right, sir.
The certification is a policy.
Yeah.
Without certification, it cannot go.
Yeah.
Now the question is, you have projected open issues,
Yeah.
and they are very important. Now, what would be the way to go? Whether you would like to have, let us say, a study team to be constituted. See, DRDO itself is a big body.
Yeah.
under DRDO or something like. My suggestion to you, because we are now, this conclave is essentially not to answer everything,
Yeah.
but actually it makes recommendation to the government or to the bodies what should be done in this area. So my suggestion to you would be that if you can write a kind of paragraph, what you feel should go as a input from this conclave to either DRDO or either to, let's say, even INAE, whether INAE can organize some kind of further study on that. That kind of paragraph you can give it to chairman.
Sir, I'll
That
do
would
that.
be very useful because we obviously don't have a solution now.
Yes,
But
we
we
don't
need
have.
to be looking at this problem.
Yes,
That's
yes,
why I get message.
yes,
So I
yes.
think if you can write a paragraph
Yeah.
on that, what needs to be done to be followed, both by
I'll do
DRDO,
that.
because you are in DRDO, and DRDO is a very critical
Yeah, yeah. We'll do that.
organization, and also in a larger system, because
Yes,
in
sir.
the
We need to
country.
have it in a larger system, actually. Yeah. It has to start from the core technology, otherwise we'll not reach
Right.
here.
Because we are worried about power grid, we are worried
Yeah,
about banking.
yes,
Our
yes.
banking software goes,
Yeah,
I won't know what
yes.
how much the account money is lost. All that is important.
Yeah, yeah.
So if you can give us a paragraph,
Sir,
that
I'll
probably
do
will be
that.
useful.
So one thing, sir, what I'll just like to add is like initially when we made the network security policy guidelines, so and we made it like a policy, and this was done under Dr. Atithan. So like we got a lot of resistance. You said don't make policies because we are not, the technology is not ready for that policy right now. So then we made guidelines. So that was the first
no.
step. So
See-
that is a good step. Start with guidelines and then go to policies.
See, I understand. See, we had a debate on that in ISRO also, that we should have guideline or policy. See, guideline is okay, but it doesn't bind you.
It doesn't bind you.
But
Yes.
policy also, you can bring a flexibility. You can say for next 3 years we'll follow this.
We can do that.
So you can do that.
We can do that. Yeah, sure, sure.
We can take up questions further.
Thank you. Thank you very much, ma'am. I request Professor Soumitra Sanadia to give a small memento to Kamini Malhotra ji.
Our third speaker in today's session is Dr. Shashwat Rajada. Um, uh, he is a distinguished IT and cybersecurity professional with over 25 years of multidisciplinary experience running the Indian Navy, where he was a commodore, global automotive corporations, and advanced research institutions. He is currently serving as Director of Cybersecurity, Technology and Innovation at Magneti Marelli. He drives global cybersecurity strategy and governance across 170 locations worldwide, ensuring compliance with leading standards such as ISO, SAE 21434, and other standards. He is an alumnus of Indian Statistical Institute, where he finished his PhD in computer science, especially in cryptology. At IIT Kanpur, our own institute, he has been an MTech in computer science from here. And he has done bachelor's in electrical engineering from Naval College of Engineering. Dr. Rajada combines deep technical expertise with strategic leadership. He previously headed product cybersecurity engineering at Bosch Global Software Technologies, where he built a global security practice from the ground up. Pioneering initiatives in threat modeling, public key infrastructure, and post-quantum cryptography research. He is a veteran of Indian Navy, where he led national-level cybersecurity and cryptographic system development programs, contributing to secure communication, data encryption, and defense network assurance. His scholarly contributions include numerous peer-reviewed publications in applied cryptography, privacy, and security architecture. He is a proven leader, mentor, and innovator, and he continues to advance the frontiers of cybersecurity, blending defense-grade rigor with cutting-edge technology innovations across enterprise, automotive, and IoT ecosystems. And he's going to talk to us today about AI and cybersecurity integration challenges in cyber-physical systems. And he'll give us an automotive perspective as he has been working in this domain for a long period of time. I welcome Commander Dr. Shashwat Rajada.
Good morning, gentlemen. Good morning, ladies. I will be, over the next 30 minutes, I will give you a perspective of what happened when cyber systems hit the automotive industry. So this is a perspective, a first-hand perspective of what we encountered. So as we know, cyber physical systems are it's the intersection of two distinct domains. The first is traditional physical systems, which are very sound engineering, which go through rigors of testing and, excellence therein for perfection. The other are computer systems where, it's a generic mission mode where you want to reach the market before the competitor, and therefore you are not very much bothered about quality, and, you cover it up with patches, left, right, and center. So it's an intersection of two disciplines which are kind of uncommon. But if you look at it as to how it interplays in automotives, we have to understand that I would just ask you, what would be a most perfectly secure car? Can you just imagine? I guess something like this, because it is not connected. So I brought up the point that zero connectivity means zero this thing. But this is not what the world is. The world has moved on. And with these new advances, there were more and more hacks on cars. But nobody gave it any thought. Till such time, these two gentlemen over here, Charlie Miller and Chris Falisic, what they did was they gave a live hacking show. They contacted this journalist, told him to buy a car and take it off. And as he was driving, sitting hundreds of miles away, they hacked into this particular car. It's a Jeep Cherokee, 2015, and the world then realized. Because sitting at remote, this hacker was able to enter the car through its telemetry unit, infotainment system, into the internal CAN, and was able to do multiple things like disable the brake, alter with the steering, switch the car engine. He was able to switch on the AC, switch off, control the infotainment system, play anything over there. So that was the time when the world woke up that yes, cyber threats are a real thing. They're not a science fiction thing. And since then, our industry, the automotive industry, is working day and night to make sure that such hacks don't happen. But they do happen. So last year, as we speak, there were around close to 26 major hacks that were there. But you'll wonder how or why does this happen? The reason is the modern car that is there, it's not a standalone one. It's connected. If you look into the slide, you'll find that there are around 16 different methods of connecting to the external world. These include connecting to the cloud. Is it? Okay. Yeah. So if you look at this, there are around 16 different ways that we have put in over here where a vehicle is connected to the external net. And every external connection is a point of entry for a hacker, which in cybersecurity is known as an attack vector. So these are the paths by which an attacker can hack in. And if external networks weren't on, we have internal networks, which are controller area networks. There are small electronic control units which are controlling different parts of the system. There are sensors and actuators connected to it. And it's a network which is inside it. It's called the controller area network. It was made in the 80s and the 90s just to save the wiring harness. And it did. About 90% reduced the wiring costs. But it created a system where there is a protocol which doesn't have authentication and encryption and things like that running. So all that the hacker has to do is use the external network to get into the car and then get into a gateway of this CAN. And thereafter, it's pretty easy for him to do anything. And that's what the two hackers had done. And then what happens is, as we are looking at these cars are getting more and more artificial intelligence, and they are moving towards autonomous cars. This slide shows the different levels of automation as defined by SAE, the Society of Automotive Engineers. And right now, in our country, we are somewhere at level 2. Tesla has moved to level 4. But more and more AI is coming, more and more models are coming into the car. And as more and more models are coming into the car, the complexity is increasing. For example, if it's a driverless car and you put in a coordinates, you want to go to place X, and somebody hacks in and hijacks the car to place Y, there's very little you can do. So as these use cases develop, the security requirements of implementing it also increase. What the automotive industry aspires to do is the intelligent transportation system, one of the domains which the previous speaker had just spoken about, where mobility she brought out. So here we want to integrate people, the road, and the vehicle together with ICT in a cyber-physical system, so that we can, do multiple applications like emergency vehicle notification. If there's an accident, you can use other way. You can have variable speed control. You can have dynamic control of traffic lights. Multiple use cases that are going to save time and make things safe. But then again, all these come at a peril. So these were the major issues that were there. And I'll take a slight digress from the core topic and just ask you, have you ever seen these kind of mails coming? Yeah? And have you seen this kind of a mail coming? Anybody, what's this? Ransomware. And I hope nobody has got it, because this ransomware means that you have to pay a certain amount in Bitcoin. Now, these use cases are coming in the car. So imagine you're driving somewhere and all of a sudden your infotainment system comes up, pay up, right? Things are so complex that you don't even have a keyboard to pay something. Right? So this is the reality of what we are going to see in the future. And it's called jackware. And it had hit a hotel somewhere 4 or 5 years back, which, this hotel went on for smart systems, cyber-physical systems, when the ransomware locked all the rooms. So the guests of this hotel were either inside the room or outside the room. They couldn't do anything. The hotel tried everything, but nothing happened. So these are the future use cases. They had to pay the Bitcoin ransom and, and then get their guests out. So such a thing hitting our industry is a nightmare. But what makes cybersecurity in this domain complicated? See, car manufacturers manufacture only 10 to 20% of the parts, the core engineering part. Balance comes through a series of suppliers. So if you look at this car, almost 80 to 90% parts are coming from suppliers. And each supplier has got its own design philosophy. He has to be bought in to understand the OEM or the car manufacturer's strategy for cybersecurity. So this extensive supply chain makes things very complicated. You have to tell almost everybody how you want this car to be secure. The second major thing is, normally, if you look at, at any other product, its shelf life is how much? 18 months, 1 year, few months. But a car has to be supported for multiple generations. So this is a car, Toyota Corolla, right? From 66 to 2006, there are several generations there. So we are looking at a lifespan, anything 30 to 40 years. Is it better? Yeah. So we are looking at a lifespan of around 30 to 40 years. So now, as we are speaking today, we have to look at future trends that are supposed to be there. Something like maybe today, if I'm designing a car, I have to preempt that another 10 years, there would be quantum attacks. There might be requirement of doing a post-quantum right now. For your information, a CA, a certification authority in India today, as per the IT Act, has its keys for maximum 3 years or 4 years. When we insert cryptographic credentials in a car, we are expected for it to serve over 30 years, and that's quite a time. So our key management, our crypto credential management has to be top-notch to meet these rigors. Another point is the amount of code that is inside a modern car, right? Somebody did a study around 5 years back, and he found out that a modern high-end car has close to 100 million lines of code, and that was around 4 or 5 years back. Now, if we look at it, it's roughly 200 to 300 million lines of code across multiple ECUs where communication is happening. And we can do a comparison with other devices which are there. So you can see those, the amount of code that has come in means there's a rule in software engineering, for every 1,000 lines of code, you have one bug. And for every 1,000 bugs, there is a one critical bug. And these are the bugs which the hackers try to exploit. And given the vast lines of codes that are there, you know the amount of vulnerability that is going to be there. And it is for this reason that the motor industry adapted standards like MISTRA very early on, much before anybody else did, mainly because of safety and security. Our next step over here is moving towards a paradigm of software-defined vehicles, where we say that, okay, let's do away with the low-power microcontrollers, bring in domains with high compute devices. So one high compute device should be able to replace multiple microcontrollers. So those kind of paradigms we are moving through, and software is therefore becoming more and more supreme, and with it, it brings its own sets of vulnerabilities. Another use case is where component replacement challenge. So you have got a car, the car has got a vehicle information, it's a specific car, it's got a specific crypto key, and one of the device goes bad, it has to be replaced. So now challenge comes, you get a device, you configure it with the keys for your configuration of the car, right? So that level of traceability we have started building into our systems, and that's the only way we can support and address the cyber challenges. Another problem that we see is your car goes through multiple stakeholders. It's not only your car, it is the car of the logistic agency when it is being supplied, it is with the dealership. If you put it into a parking lot or if you give it to a valet, it's with the valet. So your stakeholders who are handling the car change at different parts of time. When you give it to a service station, you are giving somebody your car and saying, okay, do whatever you want with it. So those are points where security or insecurity comes in, handling those kind of issues. And finally, we have an abundance of legislation that keeps on coming, and we have to adapt to these new laws and also better performance software. So all this continuous adaptation has to happen. With these challenges that we are having, how did the automotive industry reply? We came up with a thing known as standards and regulations. And these standards and regulations enabled a uniform playing field for all the automotive players. And the way it is implemented is through these challenges, through these compliances. Now, when you see UN, it's United Nations. And I'm sure some of you would wonder why UN is over here. Anybody thought? So major player in the auto industry is what is known as UNECE, United Nations Economic Commission for Europe. So what they do is, since Europe is a collection of multiple countries, they as a body have standardized requirements for automotive for these countries. And countries that are following it, they have a collaboration so that, across every country you don't have a different rule as such. So there's the standardization that has come in. And this standardization came up with these rules, Reg 155, Reg 156, and also there were a few standards that had come in. So these regulations give, any questions? Yeah, sorry. So these regulations mandate car manufacturers to perform certain actions which are supported by standards that are there. So how it works is, anytime somebody wants to come up with a new car, a new model, they have to go to a country's vehicle type approval authority. They go to this vehicle type of authority and say that, hey, this is a new car that I want to launch. So this type of vehicle type authority, he says that, okay, you want to do it, But first show me that you comply to all the requirements that have been spelled out in these standards. A thorough assessment has done whether due diligence has been performed across this entire manufacturing process. And then only the vehicle type approval will be given. Once this vehicle type approval is given, then only the car can be sold. Okay. So we had the speaker before coming up with this wonderful concept of security by design. And that's what this standard asks us to do. Security is never an afterthought. It is put into the system right from the concept stage. So today, as we speak, I'm looking at designs that are going to hit the market in 2029 and 2030, and I'm working on the security concept for that today. Okay. So this entire process starts off with something known as a threat and risk analysis, where we envisage what the threats the car would be having, what are the risks of those threats. Based on that, we build up a platform security concept. That is how I'm going to secure my car. We go in for what is known as secure implementation. We have the verification and validation, which the previous speaker spoke about. We go for secure production, and then we move on to life cycle support. So let me navigate you through these steps. Threat modeling is, we look at a car, we see what are the possible hacks that are there. We do extensive research, and then find out what are the threats. We have a mathematical modeling by which we find out the risk level, and then based on this risk level, we determine the countermeasure requirements that are there. When these requirements are listed out, we look into the car again, see what can be done at a component level, what has to be done at the internal network level, what has to be done with the external interfaces, and that's how we come up with the security concept. This concept articulates into requirements, and when we look at these requirements, it's mind-boggling number. For mid-size car, we have roughly around 40,000 requirements that are there. That's the kind of figure that we are looking at it. Then we have the next phase where these requirements are implemented. Implementation in hardware and software. We have lots of industry best practices that we need to follow. Things like MISRA, things like CERT, things like checking the weaknesses which are already been reported. So once the secure implementation is done, we have a process of verification and validation. It is done at the component level, it's done at the complete platform level. So different types of tests are put in it. So these include vulnerability assessment, penetration testing, pretty standard. But amongst all this, point number 5, fuzz testing is something that is very new and very unique for us. Here, we try to mimic attacks that have not happened. So attacks that have not happened, that have not been reported, how we do it is, we keep on bombarding our cars with different kind of malformed inputs and see how it reacts, sees what its breaking point is. We injected millions and millions different test cases, try to find out, okay, somewhere down the line, some mistake would have been there in maybe the priority scheduler or in somewhere else. And that's how we try to preempt a hack before it even happens. Once this V&V step is done, we get into secure manufacturing. Again, a very complicated business, because this is where the keys, the crypto credentials are injected. So in the plants, we have something known as plant key management system where the keys are there. This actually conflicts with the existing principles of design and manufacturing. Like you have design for testability. In your boards, you have different test points. Now, test point for a hacker is a way to enter the system. So there's always this conflict between different domains that has to be worked out. And a structured approach is done where we say that, okay, debug ports have to be closed, your fuses have to be burned, all those activities are done. Once this is done, then only can we ship the car. Life doesn't stop there. We have something known as life cycle support. We continuously monitor our cars. This is a typical way where we see that, okay, any abnormality in the car is there. So a lot of data keeps on going up and down, where we try to see that any indicators of compromise is there. So that's the detect phase. If there is anything, it has to be reported. We do a triaging, see how serious it is. If it's very complicated, an incident is raised. If it isn't complicated, it's put up for the next patch release. So this way, we are able to support our cars in the life cycle. And then we also need to update the software periodically. AI models get revised. Security bug fixes need to be put. So software being so important in the car, there is a new standard that has come up for software update engineering. It's called ISO 24089. And that is enforced through UN regulation, UNECE R156. And our country is also adopting it. It is called AIS 190. So here, the rigors are so strong that a vehicle type approval authority may tell that, okay, a specific car number, I want to find out what is the configuration of the software in its engine control ECU. So that version also I should have the wherewithal to get it out. What does my system show? What is there in existing? And the ability to update software on the fly is a big boon for the industry, because this saves me millions of dollars in recall call. If I didn't have this ability, I would have to do a recall, and a recall costs a huge amount. So this is what is happening in our industry. And to look at the next steps, what we can see is that there's going to be an increase in standards because of AI, because of cybersecurity. These standards are coming on the fly. For ITS, there are over 100 different standards that have already been published globally. So these we need to incorporate into our ecosystem also. There has to be active research on implementing of these standards. And these are just some of them. It also gives us to new opportunities in AI domain, in cybersecurity domain, in functional safety domain, in privacy domain. So there are new jobs that can be created, and a concrete recommendation would be to orient our courses towards these. And if I look, which ma'am in our first session had said, the Cybersecurity Resilience Act, it's already there in 2024, but 2027 is the D-Day when Europe will have to implement cybersecurity in each of its products. And what the CRA is wanting today is what the automotive industry has already done. Secure by design, continuous updates, almost everything is the same. And this is a great opportunity for India, because India, there are a lot of global capability centers, GCCs, which are supporting European Union products. So this is a great opportunity for us outside the automotive domain. And for looking at, again, outside the automotive domain, there is a standard known as IEC 62443, which tells how products can be secured. So this would be an interesting work body for people outside our domain, automotive domain, to look into. So this is an area where we can look into. So that's about all. Any questions?
You see, few points you must appreciate that. Number one, it is possible to design a system which will be foolproof. Outside cannot do it. I have been designing satellites and launch vehicles. I'm involved. And we do in a way that no one can have access, because we have only one receiver for receiving telecommand. And the telecommand format is actually so much secret that even I was the director of satellites, I won't know what the format is. Only one person knows. So we can discuss that. It's possible. Second, your industry has deliberately kept a facility to make it vulnerable. I know actually Elon Musk, there was a cyclone, and he actually reprogrammed the cars in this cyclone region to have extra 100 kilometers range sitting in his office. So that means he has planned that kind of a design that he can access a car even 3,000 kilometers or 4,000 kilometers away and reprogram that car. If you keep that kind of facility, you are obviously vulnerable. So when you said you have got something like 12 exit points or 20 exit points, you can operate. Actually, I would say for a car, it is a stupid thing. If I'm designing for security, why should I be? And you said you want to have a software update. For a car, why do you need software update? If I buy a car today, I should be satisfied with its feature. The moment I provided flexibility to a software update, I'm also providing flexibility to make it vulnerable. So these go together. So question is, I don't know your industry, but thinking that it cannot be done, it can be done, but whether as an industry you can do it, you can do it. So we can discuss more, but most of the flexibility part you have to take out. You know, in satellites, I don't allow use of even one interrupt, because interrupt gives you facility or capability to make it malfunction anytime. I cannot see for actually at least automobile, lack of people or maybe million of people will be testing their software. For me, it's only 3 months of software developed by 2 people. So I cannot give the flexibility. So I don't allow interrupts. Only because then I cannot debug the problems in such a short time on one or two pieces. So question is, there are possibilities of designing systems which are foolproof. But then there is a separate discipline needed, and whether it's acceptable to industry or not, I don't know. But can be done.
The challenges across different industries are there because we are looking at a single satellite or a small subset of satellite. Here we are looking at volumes which are of the order of several millions. So, so the no, so the reason why software updates are a requirement is because up there in the sky, you're the king. But here in the road, there are millions of vehicles. Every other time a new legislation comes in, say for example, there's a new law on how the lanes are to be kept. An autonomous car has to learn it. There is a new set of attacks. So all this learning can only be done when we have a method of updating the software. Yes, sir. Offline, sir.
Thank you. Thank you very much. I now request Professor Soumitra Sanadia to give a memento to Dr. Shashwat Raizada.
Before we conclude this session, I will now request Professor Aditya Jagannathan, the coordinator of this session on cybersecurity for connected systems, to kindly felicitate the session chair, Professor Soumitra Kumar Sanadhya.
Thank you very much, everyone, for attending this session. As you might have noticed, we are slightly delayed. So our tea session was supposed to be from 10:30 to 11. So we are slightly running late, but that's not an issue. So we'll make the tea from, I think we'll come back at around 11:15, 11:20 to start our 11:15, 11:20. We'll come back to start our next panel discussion. Thank you. Thank you very much. Request all the session chairs to be here for the panel. Thank you.
Hello, 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 hello. Hello, hello, eh? Santosh, hello, hello,
Hello, hello, hello, hello, hello, check, hello, 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 hello. Eh? Hello, 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 hello. Hello, hello, check, hello, hello, hello. Hello, 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 check, hello, 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 check, hello. ठीक है, थोड़ा सा.
hello, 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 hello. वो भी चला गया.
हेलो. हाँ.
दोनों एक ही साथ हैं. Hello,
दोनों एक साथ.
hello, hello.
हेलो, हेलो, हेलो.
बंद करो. Hello, 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 hello. Hello, 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 hello. ये आ रहा है आवाज? आ रहा है ना? हेलो, 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 हेलो. ये लो. आ रहा है पर इधर नहीं जा रहा है.
Hello. 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 Hello.
Welcome back, ladies and gentlemen. Thank you for being here. Uh, as all the 4 sessions relevant to the theme intelligent systems are now concluded, now this is the time for me to invite the esteemed coordinator for this theme, that is Professor Aditya Jagannatham. He is the coordinator who's kind of curated this complete theme together with these relevant speakers all across. And it is my privilege to introduce him. Professor Jagannatham is a professor in the Department of Electrical Engineering at the IIT Kanpur. He holds a BTech in Electrical Engineering from IIT Bombay and subsequently earned his MS and PhD in Computer Engineering from University of California, San Diego. His research focuses on cutting-edge wireless communication technologies, notably 5G and 6G systems, and other massive MIMO and millimeter wave MIMO intelligent reflecting services, non-orthogonal multiple access systems, and other filter bank multi-carrier systems. His deep expertise positions him at the nexus of next-generation cyber-physical systems and communication infrastructure. Among his honors, he has been awarded the Arun Kumar Endowed Chair Professorship in 2019, Qualcomm Innovation Fellowship in 18, P.K. Kelkar Young Faculty Research Fellowship, and many other honors. Dr. Jagannatham is recognized for bringing foundational research and practical applications, mentoring students and young researchers working on wireless systems, and underpin future CPS, that is the cyber physical systems. So with that, it is my privilege to invite him on the dais. Professor Jagannatham, please.
Thank you very much, Colonel, for the kind introduction. Very warm good morning to all of you again after the break. And we now come to our next session, which is a panel discussion involving all the session chairs of the sessions that we have had so far under theme 1, that is intelligent systems. With that, let me start welcoming each of the session chairs onto the stage. Of course, our first session, the session chair was Professor Ajit Chaturvedi, but he could not be here. So in his place, Professor Nilesh Mehta has kindly agreed to serve on the panel. So Dr. Nilesh Mehta is a professor and the chair of the Electrical and Computer Engineering Department at the Indian Institute of Science, Bangalore. He received his BTech in Electronics and Communication Engineering from IIT Madras and also the MS and PhD degrees from the California Institute of Technology. He worked at AT&T Research Laboratories, Broadcom, Mitsubishi Electric Research Laboratories, and he has been a faculty member at ISC since 2007. He has received several awards. He is a fellow of the IEEE, the Indian Academy of Sciences, the Indian National Science Academy, the Indian National Academy of Engineering. He is recipient of the J.C. Bose Fellowship, the Shanti Swarup Bhatnagar Award, IIT Roorkee's Khosla Award, and several others. And he is also an editor of the IEEE Transactions on Communications, IEEE Transactions on Wireless Communications, and several other leading journals. With that, I welcome Professor Nilesh Mehta to join us on the stage. Please. Our next session was AI and data science, and the session chair is Professor Nishal Kumar Verma. Professor Nishal Verma is a faculty member in the Electrical Engineering Department at IIT Kanpur, and his research interests are in machine learning, cyber physical systems, computer vision, and industrial automation. He is a prolific researcher, and he works on the advancement of AI/ML-driven techniques for pattern recognition, emotion recognition, image dehazing, health management, and many others. He has published extensively and holds key editorial positions in top-tier leading international journals and conferences in the area of intelligent systems and data-driven technologies. He serves currently as the chairman of the IEEE Computational Intelligence Society Chapter Uttar Pradesh and has been instrumental in organizing major scientific events, fostering industry academic partnerships, and mentored a good number of doctoral researchers. He is committed to advancing indigenous AI innovation, and his vision is to leverage intelligent technologies for societal transformation and national development. With that, I welcome Professor Nishal Kumar Verma to join us on the stage as one of the other panelists. Our next session in theme 1, the third session, was on drone technology, and the session chair is Professor G.M. Kamath, who is the professor and head of the Aerospace Department, IIT Kanpur. Professor Kamath is a professor in charge of the IIT Kanpur Research Park between 2021-2023 and is currently a member of its board of directors. And prior to joining IIT Kanpur, he served as various capacities in National Aerospace Laboratories, Tata Advanced Materials, Tata Consultancy Services, Bombardier Aerospace India. He obtained his degrees in aerospace engineering from IIT Madras, University of Maryland, and his research interests include aircraft structural health monitoring, corrosion sensing, monitoring aircraft corrosion fatigue of aerospace materials, amongst others. With that, I welcome Professor G.M. Kamath to join us on the stage as one of the panelists. And our last session under the theme Intelligent Systems was, of course, the session that we had in the morning, that is Cybersecurity for Connected Systems. And the session chair is Professor Soumitra Kumar Sanadhya. He's a professor at the Wadhwani School of AI and Intelligent Systems at IIT Kanpur. Professor Sanadhya heads the Center for Cybersecurity and Cybersecurity of Cyber Physical Systems, C3I. And he's also the program director of C3I Hub, an organization working towards translational cybersecurity products at IIT Kanpur. He is an alumnus of IIT Delhi and obtained his PhD from ISI Kolkata. His research interests include design analysis and efficient implementation of cryptographic algorithms and protocols. He leads many initiatives in these fields, including mentoring startups, running academic programs, executing projects with many Indian government agencies and corporations. And with that, I welcome Professor Soumitra Sanadhya to join us on the stage as one of the other panelists. Thank you very much. So we will start our panel discussion, and of course, I will ask, we'll start with a brief summary of each of the sessions, and then we will open it up with questions from the audience.
So I now request the session's chairs to present a brief summary of each of the talks in their session and some of the key recommendations. We will start with our session 1 in theme 1, which is next generation communication network. So I request Professor Nilesh Mehta to present a brief summary of the session and some of the key recommendations or some of the key conclusions from the session.
Right. Thanks, Aditya. The session was titled Next Generation Networks, Next Generation Communication Networks. And we had a diverse array of topics covered in it. There were 3 speakers. The first was Dr. Kirti Keshav from Samsung Semiconductor India Research. And he basically spoke about 6G, its challenges and the key future directions. I think the point he made was that it's a fairly significant shift. It's going to be AI native, energy efficient, and also the key point he made was it's going to unify communication systems for the next decade. I think he spoke about topics like integrating terrestrial and non-terrestrial networks and also sustainability. Also, I think what I found interesting was he discussed several technologies that he said were there in 4G or 5G but disappeared, but then they came back again. So he pointed out that some of these ideas carry over and they just find new contexts there. So that was Dr. Kirti Keshav. And I'll also mention what sort of recommendations he made very briefly. So I think the key point was the 6G research should build on current 5G releases, focusing on the topics I mentioned, which is AI nativity, energy efficiency, and cost efficiency. He also talked about the FR3 band, the 6 gigahertz band, which is the new band for 6G, and techniques like distributed MIMO, terrestrial, non-terrestrial integration, and a lot of testbeds need to start focusing on this. I think that was the recommendation made. He also recommended a strong collaboration between academia and industry, I think something that I endorse, and also participation in global bodies, which would be 3GPP and ITU for shaping a 6G ecosystem for India. So that was the first talk. The second was by Shri Manish Pratap Singh, DRDO Young Scientist Laboratory Director, and he spoke on federated learning in 6G or IoT or wireless communications. I think the point he made was that federated learning is a nascent new technology, and it's a key enabler of distributed intelligence in 6G systems. He pointed out that it preserves privacy, which is one of its big advantages. Also, it reduces the communication overhead. And he discussed its applications in defense, IoT, smart infrastructure. He also pointed out some challenges like how to scale it, how to make it secure, how to handle heterogeneous data sets. And he also had a couple of recommendations to briefly summarize them. He said, I think you have to develop these kind of federated learning networks that can handle heterogeneous data, and also the fact that the devices have very limited resources, unlike servers. And he kind of spoke about different architectures that could be looked at. For example, hierarchical architectures. They have to operate in real time. And he also spoke about collaboration between research institutions and defense labs. So that was Shri Manish Pratap Singh on federated learning. The third topic was on next generation Wi-Fi, and that I was the speaker. So essentially, the point I was making was that Wi-Fi is as central to 6G access as the cellular systems. It's evolved rapidly quite a bit over the last 2 decades. I discussed some technologies that have led to this massive improvement in its performance, and also discussed about what the future could potentially incorporate, such as techniques like full duplex radio. So some of the things I mentioned was, I think we need to very aggressively work on Wi-Fi innovation as well. That was one of the recommendations, besides cellular innovation, and also look at new techniques as well as new applications for Wi-Fi, for example, in the industry setting. So with that, I'll close my summary. I think it was a very interesting set of topics.
Thank you. Thank you very much, Professor Nilesh Mehta, for that wonderful summary. I next invite the session, chair of session 2A, AI and Data Science, Professor Nishchal Kumar Verma, to present a brief summary and key recommendations of the session.
Thank you, Aditya. So, as mentioned, I was the chair for the session 2A, AI and Data Science. And in this session, we had 3 talks. The first talk was on AI as skilled engineering assistants, opportunities and challenges, by Professor Amrutur Bharadwaj, professor from ISI Bangalore. So here is the overall summary of the talk. Basically, the talk focused on how AI can revolutionize engineering education and practice through the concept of an AI generalist engineer. In short, it is AIGE, and capable of solving any engineering problem. He emphasized that intelligence is becoming a commodity, democratizing access to knowledge, and transforming the way engineers learn and design. And here are certain recommendations from the talk. And it's basically on engineering education that should integrate AI-driven labs, simulation labs, and project-based modules to promote hands-on learning and prepare students for AI augmented engineering environments. And research industry collaborations should also focus on building domain-specific information related to AIGE and foundation models that can accelerate design, manufacturing, and sustainable efforts. So basically, overall, a strong push towards interdisciplinary innovation is needed, encouraging startups and researchers to combine AI with fields like bioengineering, robotics, and engineering for impactful cross-domain solutions. The second talk was basically on transforming biomedical research using AI by Professor Sanghamitra Bandyopadhyay from ISI Kolkata. This talk gave overview of how AI has evolved from early perceptrons and expert systems to modern neural and graph-based neural network models and its transformative potential to biomedical research. Professor Bandyopadhyay illustrated how computational AI methods can decode complex biological data, accelerate drug design, and predict adverse drug interactions using graph neural networks. Emphasizing a problem solving mindset, she advocated for India's focus on indigenous biomedical standard datasets, scalable healthcare solutions, and context aware AI systems. The talk balanced historical perspective, technical innovations, and forward looking vision towards data driven, affordable, and inclusive healthcare. So, here are certain actionable recommendations. Professor Bandyopadhyay basically emphasized towards prioritizing building large scale, high quality biomedical data sets, which is really difficult, and we are actually it is not usual, and there is a need to have such data sets in order to be self-reliant towards developing a biomedical theme-based AI systems. So, a high-quality biomedical data sets capturing clinical, genomic, and imaging data representatives of the Indian population. Also, the healthcare AI systems must adapt the community level personalization approach, designing scalable solutions that provide affordable yet contextually accurate care for diverse demographic groups. Also, Professor Bandyopadhyay mentioned and emphasized towards collaborative research should unite clinicians, biomedicians, and especially bioinformatics experts, AI experts, and policymakers to solve problem-driven national health challenges rather than focusing solely on algorithmic development only. Regular re-evaluation of global diagnostic standards against Indian dataset is needed to avoid systemic under or over diagnostics and ensure fairness in medical AI applications. And the third talk was on synergizing AI with industry norms, design, paradigm, and certification framework by Dr. Subrata Rakshit. Dr. Rakshit actually traced the engineering evolution from classical physical systems designed through software engineering and into the current era of AI. He argued that AI is as different from software as software was from hardware, and thus necessitates the new design requirements and certification paradigms, not simply extension of the past methods. The talk is stressed upon the importance of industry and user, regulator, synergy, explicitly shifting risk from upfront to post-deployment. The important themes concluded the reframing requirements through labeled data and examples, establishing calibration data sets and reliability metrics, the familiarity especially, and the competence, and building certification frameworks for trustworthy AI systems. And there are some actionable recommendations from his talk that I would like to mention here. He recommended that AI systems must be designed with the understanding that most risk customization, drift, and adaptation emerge after deployment. Hence, contracts, monitoring, and recalibration processes should be built into life cycle management. He also mentioned that requirements should move from the textual descriptions to label data and boundary examples with the clear standards for data set, adequacy, diversity, and class coverage to support reliable design and testing. So he also stressed upon the regulatory calibration and certification framework should be established where OEMs provide baseline calibration sets, user validate through challenge sets, and believably the metrics, that is familiarity and competence, ensure transparency without requiring IP disclosures. So with that, this session covers the whole idea of the theme of data sets, the AI and data science.
Thank you very much, Professor Nishal Verma, for providing that nice summary on the session on AI and data science. With that, we move to the next session, that is our session on drone technology, and I invite Professor Kamath to present a brief summary and key recommendations from the session.
Thank you. Good morning to everyone. So I'm going to summarize the session on drone technology. So there were 3 talks, one by Professor Ghosh from TASL, but I take the talk as something that came from IIT Kanpur, and I think you'll see why. Second was by Mr. Prashant Bhadoria from TASL, Tata Advanced Systems Limited, and third was by Dr. Abhay Pashkilkar, Director, National Aerospace Laboratories. And before I start, just a short disclaimer that I obviously have put in my own filters and biases into what I took away from these talks, and so please forgive me, and doesn't fully, if there's anything I misrepresent, it's my fault, not the speaker's fault. So, and the other broader theme that I see from these 3 talks is that, interestingly, I mean, this is something which, Professor Ghosh focused more on what academia could do and how, it can seed or spawn, innovations, new technologies, even before it becomes, something that the world needs. So that's, and then I look at, Dr. Pashilkar's view as an enabler, and you see it's almost like, going through the TRL steps, and then, NAL being an enabler of technologies, trying to bridge, and of course TASL being the production agency or the final integrator, if you want to call it. So it was a very interesting set of talks, which kind of gave a good overview of what is necessary, what needs to be done, and how it could be done as well. So that's like broadly what I think is my takeaway from these 3 talks. I'll go a little bit more into the details of each one right now. So first, covering Professor Ghosh's talk. So it was kind of a bit of personal history as well as to how his students started getting interested in developing, and this is an important lesson for all of us. I think you never know sometimes where curiosity and passion can lead you to. So how students started developing drones and ultimately got formed, the Aurora Integrated Systems company got formed, and I think many of you may know that it was ultimately acquired by Tata Group as well. So he emphasized the importance of nurturing this kind of curiosity, innovations in academia. He also made an important point about, and this is something I think all three of them made a point about how Operation Sindoor was a kind of a, a watershed moment for all of us in terms of what was needed, what we were capable of, and I think, and it also obviously highlighted some of the gaps that we have, and I think which we should focus on. So if I look at it from Professor Ghosh's point of view, he highlighted a lot of key research areas that we should be looking at, like things like cyber resilience, swarm technology, GNSS denied operations, which incidentally other speakers also emphasized. And he also spoke about some of the key pillars that if a center of excellence were to be created, what are the key pillars that this should be resting on. One was AI and autonomy, communication, energy and propulsion, and system integration aspects. So from a actionable recommendation, I think one very nice, I mean, from my personal perspective, is that, and I think he suggested that we do something along the lines of the Integrated Guided Missile Development Program, right? So his point was that why can't we, like how you have, Agni, Prithvi, Trishul, Akash, and so on, why can't we, and of course, yeah, one important point I want to emphasize here is that although Dr. Pashilkar spoke a little bit about agricultural applications and so on, but this was a largely aerospace and defense kind of a focus that all these three talks had. So I don't think we are going to go too much into other use cases. So it will be mostly from a defense and air mobility, air taxis, or from a counter warfare, I mean warfare kind of a perspective. So to that extent, he felt that we should have something along the lines of IG Integrated Guided Missile Development Program, where we identify key specifications of, say, maybe 3 or 4 or 5 drones which are important for the country, and say that these are the key specs that we have, these are the 3 key vehicles or platforms that we want to develop, and what are the technologies needed for it. So that becomes like a top-down kind of an approach, where we start with the specs and then go down and see what are the technologies, who has to develop it, and so on. I thought that was an interesting suggestion or idea, that, and I think that's a very actionable kind of a recommendation. And of course, the R&D efforts that I have already spoken about. So coming to Mr. Prashant Bhadoria's talk from TASL, he gave a perspective from the industry as to what are their initiatives, what are their current activities, what are they working on in terms of meeting some of these needs of the country, including large UAVs, and mostly in terms of payload. So I think that was also an interesting set of mostly avionics, payloads related to surveillance, ISR, and other applications. So there was a lot of emphasis on indigenization of these very critical equipment, the avionics, the computers, and navigation systems, sensors. So there was a lot of emphasis on that, and that's also, I think, a key takeaway from Mr. Bhadoria's talk. In terms of actionable recommendation, I would say, I think identifying key technologies for indigenization, this is also, I would say, is one of the recommendations from Dr. Pashilkar. I'll come to that. But so one is definitely indigenization. And in terms of the technology needs, he raised this issue of, again, resilience, which again, even Professor Ghosh spoke about. Resilience under different challenging conditions, difficult conditions, like GPS denied or GNSS denied environments. He also spoke a bit of certification aspects. He felt that one of the actionable items could be in terms of sensitizing certification authorities to hasten the certification process so that the development cycle is much faster. So that was the second talk. In the terms of the third, so Dr. Pashilkar started his talk with giving a broad overview of all the use cases, in terms of civilian applications, defense applications, exploration, survey, and so on. He also spoke about NAL's efforts in developing high altitude pseudo satellite systems and some of the drone developments as well. But again, one of the key takeaways for me is that he suggested that NAL could be looked at as a multi-stage aggregator, and he also suggested that we should, I think this is kind of what I see as Professor Ghosh's recommendation. He said what he called as demand aggregation, right, in terms of deciding what are the key specs or what are the key requirements of the country, whether in a specific application maybe, but since we are talking of defense, so he also advised the idea of demand aggregation, which was an important suggestion. The other interesting takeaway, or I would say it's even actionable recommendation, is development of a drone stack. And I think that's again a very important suggestion, and I think it's very actionable. What are the key elements of the drone stack? How can we develop? Who's to develop? And this will go a long way in kind of strengthening the ecosystem and developing the robustness of the ecosystem. And of course, he also identified some of the key technologies to be indigenized. And or rather, he said that we should identify some of the key technologies to be indigenized and developed and so on. So I think with this, I would say that it was actually a very good, a kind of a broad overview of, from different aspects, from an innovation aspect, from developing the enabling technologies versus what are the production issues and so on. So I think I think it was an overall a very good session with a lot of different perspectives. So thank you very much.
Thank you very much, Professor Kamath, for that wonderful summary. So with that, we come next session, that is cybersecurity for connected systems. And I request Professor Soumitra Sanadia, to the session chair, to present a brief summary of the key takeaways from that session. Thank you.
Yeah, thank you, Aditya, and good morning, everyone. So this session, which was held most recently, it had three speakers. The first one, well-known academic expert from IIT Kharagpur, Professor Deepanita Roy Chaudhary. She talked about implantable medical devices and the security issues in it. In the second talk, Ms. Kamini Malhotra from the head of evaluation group at the SEG lab of DRDO, she talked about policy issues in interconnected devices. And the third talk was by industry expert, Commander Dr. Shashwat Rajada, who talked about vehicular security and the policies and processes which are followed in industry for this domain. So very diverse topics were discussed, and I would like to now emphasize right from the first talk, what were the key issues that Dr. Deepanita Roy Chaudhary mentioned. So she talked about this emerging area of interconnected, this medical devices, implantable medical devices, IMD, and there is not much happening in the country in this domain, and she emphasized that firstly, we have to think about the algorithms, the lightweight algorithms which can be implemented on such devices. So there is a lot of research needed in these, because these devices don't even have much energy to consume. So we want these algorithms to actually be very efficient from energy point of view. From cryptography perspective, for example, we know that if you look at certain public key algorithms, they take huge amount of energy to implement. So therefore, she has already even shown some examples of the kind of work she has done in lightweight cryptographic algorithms. And she also mentioned that in some cases, we do not even want just encryption, maybe authentication enough. Some cases, we only want authentication, but encryption is not required. And in some cases, we require, based on the application, both authentication and encryption, and which is the area of authenticated encryption. And she mentioned one of her recent works in which this lightweight authenticated encryption algorithm was developed. She also mentioned about the protocol, that is the next level. Once the algorithms are in place, how these algorithms are going to interoperate and talk with the device outside, because the data has to be shared about the user's medical record, etc. And she talked about development of protocols, and finally she talked about the ASIC development, and which is to implement these algorithms in hardware. And in all these three areas, there is a lot of work left to be done in the country. And she also made some specific recommendations. So first, she mentioned that we need a IMD security program at national level, which is to prototype an ASIC, standardize some lightweight protocols and lightweight algorithms. She also said some data set or requirement standards are to be designed, which can mean commands, corner cases, safety envelopes, etc. She talked about energy efficient and software co-design, because not everything need be done in hardware. If there is a software component, then this can also be updated as per the requirements in future. Of course, security has to be considered in all of them. She mentioned at the end about building a shared incident and threat intelligence clearinghouse, where clinicians, hospitals, vendors, certain academia, all are involved. So that the data comes from all places, and some this rapidly coming up, this safety exploits, etc., can be tackled very quickly. In the second talk, Ms. Kamini Blothra talked about policy and verification in these connected systems. And by policy, she meant machine enforceable rules for configurations, for access, for data flows, for behavior, user behavior, and for zero trust across data, types, devices, etc. And she mentioned some of the so techniques of formal verifications which have been used in DRDO. She mentioned a specific example of the I project from DRDO, which is actually used, which actually has a formal verification as its basis. So it was nice for me to listen that such formal techniques are actually finding implementation and usage in DRDO. So she talked about data provenance, so that we know that it's not just the data, but the data is also carrying the story of from where was it originated and to whom it passed in between. She talked about micro-segmentation to create these mission enclaves for the security of the data. She talked about edge-centric enforcement to stay resilient even when disconnected. And she gave some specific recommendations, and that is to adopt a hybrid policy architecture where the central formal specification or verification can be done with federated edge decision points and attested gateway or device enforcement. She mentioned about this mandating provenance of the data and verifications, for example, from trusted enclaves or from remote attestations, etc. And this will allow us to have cross-domain data trust and auditing later on in case something goes wrong. She mentioned about deploying context-aware micro segmentation and in particular the use of AI in these segmentations. She also talked about integrating formal methods, as I just now mentioned about the DRDO's I project, which also has this continuous scan for conflicts or hidden paths in these policies. And finally, she talked about engineering for disconnected operations, like we should have a method for pushing policy caches and local verification, and these kind of push can be made to the edge. In the third talk, Commander Dr. Shashwat Rajada mentioned about vehicular security architecture. In particular, he started with an example of a huge number of cyber attacks on connected cars in 2024. He also mentioned why it was needed, because recall is very costly for this industry, and there are different kind of devices, different kind of vehicles which are plying on the road. And he emphasized security by design, and he actually mentioned about this fast emerging landscape of ISO and IEC and other standards in this domain, many of which were very new to me, and it was very pleasant to listen to these kind of things. Uh, he also mentioned about this EU Cyber Resilience Act, which is going to come into effect in 2027, and the opportunities it presents for Indian organizations and companies. Uh, to summarize, he actually talked about in-vehicle networks, which are having heterogeneous buses like CAN, LIN, Ethernet, etc., and different gateways which are complicating segmentations, diagnostics, and this secure update orchestration. So secure update is a very dangerous thing to do, as was also mentioned by our colleague from DRDO. But it is necessary in this particular application case. He mentioned about automation and AI, in particular how the progress in SAEJ 3016 standard is taking place. He mentioned about ML specific risks, some of which were also mentioned in earlier talks. For example, Professor Parthapratim Chakravarti mentioned about how images, the speed data on the speed pictures on road can be minutely changed so that human eye doesn't differentiate it, but the machine will read it differently and will do something else. So he actually came back to those kind of attacks as well. And his big emphasis was on compliance, because again, this industry works on compliance. Novel attacks can possibly be defended or may not be defended. They will come with time, but compliance is something which airline industry, the car industry actually heavily relies on. And he talked about different kind of standards in engineering. He talked about this CSMS, this UN standards. He talked about ISO 26262 standards and the AI guidance, which has recently come up, and the AI risk management standards, and how they align with this European CRA standard, which is going to come up soon. And as an actionable item, he mentioned a few things like co-engineering safety and security right from design, and to harden the CPS stack, the cyber physical system security stack, which is to have segments in network networks, in vehicle networks, enforce this least privilege gateways, and deploy runtime intrusion detection systems, which we normally see in laptops and desktops, but he argued that this should also come to the vehicles. He mentioned about obligations under the CRA Act of the EU. He mentioned about institutionalizing AI risk management, and that is to apply ISO or ISC 23894 with safety guidelines from other ISO standards. So these three were very diverse but very interesting talks in the session which concluded just before our discussion. So this, again, I would like to thank all the three speakers and all the people who are listening and asking wonderful questions. Thank you, Dr. Aditya, again to you.
So I thank all the session chairs once again. Thank you very much for presenting these wonderful summaries. So I have a couple of questions for the session chairs, but what I can probably do is I'll start by opening up to the audience. Maybe we can take a few questions from members of the audience, then I'll come back to a few questions. Please provide mic.
Not really questions, but I thought I'll make a suggestion. See, this forum in INAE, we are not limited by what speakers have said for making recommendations. So we can go beyond. That's one thing, because ultimately the President INAE will carry these recommendations to the corresponding, maybe secretary, maybe planning commission, maybe equivalent of Niti Aayog. So they will do that. So please don't limit yourself. Second thing is, I just have few observations. See, in biomedical, I thought a very important aspect of biomedical emerging today is synthetic biology. And synthetic biology is going to be a bigger tool, in my perception, when you are looking for a technology revolution. Then after AI, it is synthetic biology.
Okay.
And it's necessary for us to catch that right now,
Right.
before you can say someone discovers that we are lagging behind. So, and particularly because we are talking of now intelligent systems, synthetic biology will be very important either for defense as well as for the security, or maybe fighting the diseases. So that part I would request you to include as a part of your recommendation. Who does
Noted.
it, whether it's a biotechnology department probably should look at it. So INAE can make a specific recommendations.
Noted.
For the drones, I thought there's one element which we have not really discussed. You see, drone today, in my perception, is like a car. You have a different kind of cars. Car manufacturer does not produce most of the things. He produces very little things. Drone also, actually, when we are doing that, all our startups, they are buying things from Singapore or China. Point is the component of drones, whether it's a motor or whether it's a propeller, no one is making. So we have to give a recommendation that something, see, we have a lot of funding mechanisms, and recently new funding mechanisms are coming. So actually, the funding mechanism, wherever it is, maybe in the DST or a, should focus that someone should make a motors for different kind of drones. See, what will be important? Important will be efficiency and weight. When you look at the literature in the world, yesterday only I was reading, someone has produced a motor 59 kilowatt per kg. That is probably one order of magnitude better than what we are doing in this country. So we have to give much more focus on that if we want our industry as well as defense to take up these products. So someone we should really create a center of excellence for making motor, making propellers. So some of these elements that, like car industry has, actually Maruti, what it did in the country. Maruti was the first company in the country in 80s. They said, we will not produce anything. We'll get it produced by the industry. So they said someone will make an engine or someone else will make it. And all the ecosystem in the country for car manufacturing totally changed. Otherwise, we had a model of ambassador. They were making everything. So I think that model we have to adopt for the drone. So that's what. One more suggestion was with respect to, I was just trying to recall our discussion on.
Last, just to Professor Kamath, since you talked about drone technology, if I can want to see if Professor Kamath wants to add anything to what you have said about, if you can add briefly. Maybe.
Okay. Similarly, when we are talking about safety systems and all that, we have to generate standards. And again, we have to really, see, this recommendation came from DRDO. We have SEG. SEG looks only for, let's say, defense systems. But actually, we need a larger system. So we need an equivalent of SEG for our commercial systems. We don't have mechanisms like that. So, of course, in that also, someone said, I'm not very sure, because I've been RSC chairman there was not such a secrecy. But someone said to me, no, SEG does not say why it's not acceptable. So I think we have to create an equivalent of SEG for the commercial systems, where the software will be, you can say, from security point of view, certified. Yeah, this particular software is having this safety. So I think we can kind of, that can be done probably to the either Ministry of IT and all that. So I think that kind of recommendation will be more useful. I mean, in it is just these few thoughts came to my mind.
So
Professor
for
Sanandya,
the
go ahead.
last point that sir mentioned, so I would like to actually say, from what little I know, so there are different ways of doing. One is what Dr. Rakshit mentioned sometimes, that if you want to do something in a very secretive manner, then maybe the chip or the hardware should only be able to do that, nothing more than that. Okay. So that is a kind of direction which he used to say sometimes in KR Bangalore, that why have 10 different things in the system if we want security to be the most important aspect? Then focus only on that aspect and not do other things. The other things can be done by other systems. But the second thing, when you talked about the software security, so software security is an extremely hard area. Okay. I mean, people have even attempted theoretical proofs, and the problem is that it takes a huge amount of time to have a formal AI system. I was in NYU recently, just last month, and I was discussing with a professor about exactly this topic. And he mentioned that many years ago, they actually tried this kind of a thing. It takes few years to prove a few hundred line software to be proven secure formally. And the point is, the moment you change a single line, update happens, the entire analysis goes. Because the single line change in the code will make it is possible to have a completely insecure system.
Professor,
So
we have lost two launches
yes, sir.
because of software errors.
Yes, sir.
So I know exactly
Yes, sir,
what has
certainly.
gone
So,
through. and
what I wanted to say is that in some cases, what I know, again, some agencies in the country do is they do a kind of operational testing, which you must have certainly been doing. And along with that, test cases in security, trying to simulate different kind of scenarios, which again, I'm sure you must be doing. So these kind of a thing, I have also been involved for one agency, and Commander Shashwat Raja actually introduced me to them. So I did one project with them for software security. So this is again a challenging area. So
one more suggestion I would
Yes,
like
sir.
to make with the software security is what he mentioned that you have got 12 ways of reaching the car. I'm saying it is a stupid design. Who's ever designed it? Actually, there should not be any mechanism of reaching the car through RF, or if at all, maximum one. In fact, I am against even one. You should be able to, put a catch and do that. So that kind of recommendation also probably, at least for our industry, we should not do the way Americans are doing. Elon Musk deliberately does it because he wants to really play with the system, and no one should buy anything else. But we can't go with that kind of a scenario. So that kind of recommendation also, I think we should make of that. Thank you.
I know you, the winner. I have to follow some. Let the panelist handle it. Just a second. Any other, some few of the audience members can go ahead, please.
So, sir, this question is about AI-based medical image diagnostics. So, I will ask Professor Nishal Verma, sir, for this. Sir, a lot of AI-based medical imaging automated diagnostic systems are being developed, and a lot of research is being done. But since we know that AI-based systems make mistakes also, and they depend on datasets availability, so do we have any policy or any kind of regulation, national level, which will allow us for commercial deployment or clinical deployment of such systems if developed? Thank you, sir.
Thank you. So yes, you are very right. Actually, the major challenge and bottleneck is the data set, right? For biomedical, diagnostics. We do have a very advanced models, but finally, the bottlenecks that we have for this is the data set. So data set, whether it is a cancer data set or maybe any other related data sets, we are suffering from, or we are relying the data from, major, mainly US labs, right? And there is a time now to put complete focus on creating the data sets, and that too, the standard data sets, right? So that is actually the recommendation. And I don't think we have in India those kind of data sets for medical diagnostics. We have very advanced tools, AI-based tools.
So very good. Thank you very much, Professor Nishal Verma. So I think we can take few more questions, but before that, one question for each of the panelists, which is basically pertaining to, so we have of technology, and of course you can see we have a lot of and bright and enthusiastic students. So I want to ask each, it's about how can we develop, or what you like to give these students regarding preparing themselves for a career in these areas, in these frontier areas of technology. So starting with Nilesh Mehta to tell me we should prepare students for 6G technologies for development of 6G technologies?
Okay, so to answer that question, I'll ask a question to the audience, especially the students. Uh, how many of you have taken a course, for example, either in communications or networks in the audience? Wow. Okay. So yeah, I think that's fundamentally where the issue is. So I think we need some sort of electives. I don't think any of this should ever be compulsory, but essentially there needs to be choice where some students who are interested in the broad area have the option of taking it. And then of course the thing will take over. I think we need those fundamental courses to be offered as electives and then taught well, and then the students will take.
So which are the fundamental courses you're talking about? Communication systems, is it?
Communications and networks.
Communications
No
and
6G whatsoever should be taught at the undergrad level. I
Okay.
think it's just too advanced or really too specific. The foundations need to be laid so that today it's going to be 6G, very soon it'll be 7G, then 8G. So I don't think we can run after that. I think if your foundations are strong, I think you will cope with it for over 2 decades.
Thank you. So, Professor Nishal, what do you think students should, who are aspiring for a career in AI and data science, how do you think they should prepare themselves, or what are your suggestions for to prepare the next generation of the workforce for AI and data science?
Thanks, Aditya. It's a very important question, especially the students or the interns that they come to us for learning AI and related applications. What we understood, they lack the understanding of AI related algorithms, the understanding of the algorithms, the working, right? See, basically the students, those who are coming for AI, they are thinking that only the applying the toolboxes and other things will help. You can get the model built, model trained using some standard data sets and the models available, but then that is not the proper understanding of AI. AI actually refers to, especially from the engineering point of view, see, it is the model that learns by itself, learns from the data, right? So better is the algorithm, better is the data, better is the algorithm, better is the learning. So that is what is a very important aspect of AI. And the students or anyone whosoever is interested in practicing AI in real sense should focus on understanding on the algorithms and the basis on which the models are being developed. So that's what is the message from my side, Aditya.
Thank you. Thank you very much, Professor Verma. So again, to Professor Kamath, the same question, but a different technology related to, so we've seen a lot of excellent drones, both from, I think, NAL and also TSL. And of course, I think all of the students are excited about opportunities in drone technology. So for students who are aspiring for a career in drone technology, what do you think, what is your suggestion to them? What should they focus on and how should they prepare for working on this next generation drones?
I think all of you are familiar that drone is actually a system, right? I mean, it's like the common refrain that ISR always says that I think they have very few aerospace engineers in ISR, right? They have electrical engineers, mechanical engineers, because it's a system integration. There are components, there are subcomponents, there are sensors, so you need everything. So I don't think there is one magic bullet for drone technology. I would say, if I go non-technical and go into more of, I think it's more important. My personal view is more of, the curiosity and the willingness to learn, because it's you have to span across disciplines. You might have to go beyond what you might have been trained in electronics, but you might need to understand a bit of aerodynamics, or you might be trained in mechanical engineering, you might need to learn a bit of electronics. So I don't think, of course, in a more lighter way, I think IIT Kanpur offers an MTech in unmanned aerial systems, which is funded by Ministry of Electronics and Information Technology. And I think it's probably one of the very unique programs in the country. So you're welcome to apply to that. There we give a more comprehensive, broad-based idea of what it takes to build a unmanned aerial system.
So just a follow-up, is this MTech in unmanned aerial vehicles, is this open only to aerospace students, or is it for students who have bachelor's degree in any other stream of engineering?
Other streams as
I think that is an excellent opportunity for the students who want to learn more about drone technology. That's a wonderful opportunity.
Sorry,
And I
just
think
to add to that, and incidentally, although it's led by the Aerospace Engineering Department, but it's actually, it has faculty from electrical, computer science, mechanical, even earth sciences, because that's also a good use case for surveys and so on. So it's not just an aerospace engineering program. I would say it's an IIT Kanpur program, which involves multiple departments in the faculty.
Thank you. Thank you very much, Prasaka.
Sorry for that quick plug.
No, it's a wonderful opportunity. I think many students would be definitely interested in applying to that program and, furthering, I mean, those who are especially interested in drone technology. So again, we go to the next chair, that is Professor Soumitra Sanadia. I again have the same question to you. So of course, cybersecurity was one of the most upcoming and emerging areas of technology. So what is your suggestion to these students who are aspiring for a career in cybersecurity? Or how do you expect them to prepare?
So just like most modern areas, cybersecurity is also very, very wide. And it is not different in that sense from drone technologies, as Professor Kamath was mentioning. There are various different directions from where you can enter into cybersecurity. Is the mic working? Okay, yeah. So, for example, there are people who are working from the algorithms point of view. So develop authentication protocols, authentication encryption algorithms, and so on. So they need to have a very good understanding of maths and proofs. So those who think that maths is of no use to them, why first year BTech they are teaching courses like this, abstract algebra. You wouldn't even realize, I did the same course in my BTech first year in IIT Delhi, and I had no clue why I'm being taught groups and finite fields and rings. Okay, it is only when I started my research and I realized how useful this is. Your entire, today when you log into Google, you see this lock icon and HTTPS. That S is secure HTTP, and that is being enabled only because of number theory and this abstract algebra. So it is not very easy for a young student to understand where this knowledge is going to be useful. Not even just young students. I give you the history from Hardy, whom we better know from as a person who called Ramanujan to Cambridge. So Hardy was a great number theorist, and he disliked what we call today as applied mathematics, any math which is used in some application. And in his great book called A Mathematician's Apology, he writes, he takes pride in the fact that my area has no practical use. And he feels very proud about it. He didn't live long enough to understand that today's modern cryptography, the RSA, Diffie-Hellman, everything relies on precisely that number theory. So that is one thing I want to tell people. Don't think that some subject which is being taught to you, especially these core abstract subjects, they have no meaning. They are actually very, very useful in doing things much later. Even the matrices, for example, when they were taught initially, certain mathematicians who were reviewing these papers, they rejected those papers. They said, oh, what have you done? You've just represented the data rather than a single row. You've just written it in a two-dimensional form. So how does it bring anything new? But can you imagine any engineering today? Forget about computer science. Any engineering, the entire graph theory, the entire fluid mechanics, everything relies on matrices today. So that is one direction that I want to tell you. The second, if you want to enter into this security, development, software side, you have to start thinking a little negatively. Think about it, that you are a teacher who has to catch students who are cheating. Okay. Now, in my generation, what would people do? They will leave a cheat in the bathroom. Okay. They will carry a cheat in their pocket somewhere, and you will catch. Today's generation, I mean, you can think what they are doing. Somebody can think of getting a AI-enabled glass, and which companies are already selling. They take automatically pictures. and they project something back on your eye. So you can actually take a picture of an exam paper while appearing in the exam and extract this data, send it back, and somebody else will solve it from outside, send it back. You are sitting in an exam hall, taking an exam, and maybe one of the machines has been compromised. Okay. And using that machine, the entire LAN can be compromised, and somebody is giving you answers on your screen and not on the other people's screen. So there are different ways of thinking. Sometimes I teach an example in my class. Think about you are implementing a Superman. Okay, so there is maybe the Superman is standing there. There is a bank here in which some innocent person has been put on a gunpoint, and he's being threatened. And as a Superman, your job is to save this person. And just beyond this building, there is another bank on the other side. Now you program like this that the Superman has to travel maybe 20 feet. Then he has to break open a window, enter and look at the person who is being held at gunpoint, catch that person and come out and take him to a safe location. So this is the program you are writing in some language. Okay. Now, if I'm a malicious person, what will I do? I will try to use this program knowing that it has Superman power. Can I misuse it for myself? I know the other side of the building is a bank, which I want to rob. So what I'll do, I'll keep one of my person with a fake plastic gun, and I will ask him to go to the bank. He will go to the bank and stand there. Now I want to flip this behavior of the attacker in the sense that the Superman should go, but not turn left, but it should turn right. Break open the window, so he will break open the window of the bank. He will find somebody who is being held at gunpoint, and he will carry that person to a safe location. Now, how do I achieve this? By just a small change in the behavior of the program. As a Superman, I will simply lie the belly up. So rather than going left, I will go right at the end. And I will actually break open the window of the bank. There is a guy already standing for me. He will keep a gold bar in the hand of the person and put a fake gun on top of his. The Superman will catch hold of this guy, take him to a safe location, 1 kg gold bar. So just an example of how a simple thing can be modified. And this is the problem with software security that I was mentioning. You have to think like an attacker. So normally as a human being, we were evolved to think like positive. You are going on a road and somebody tells you that, oh, there is a traffic accident there, don't go by this way, and he's coming the wrong side. You go a little ahead, you see another car coming the wrong side, you will normally you will believe them, and you will also turn. But in software, you don't believe. You have to have some mechanism of understanding whether the information that you are getting is correct or not. And that actually requires a different mindset, the mindset of a hacker, the mindset which always thinks like, maybe this is not true. And this is where all the scams happen today. You get an information and your mind by evolution starts to behave that it is correct information. So in security industry, you have to start thinking that anything that you are getting is by default wrong. You have to have a way of proving that the thing is right before taking any action. So this requires a different thinking. This requires therefore a different way of programming also. So by default, assuming everything wrong. And so my recommendation by these examples is that when you enter into the softwares or any kind of a security domain, you have to change your thinking into thinking like an attacker before you can defend the system. Thank you.
Thank you. Thank you very much. That's a wonderful, I think, wonderful set of recommendations for students who are preparing for careers in these areas. Let's go back to the audience. Let's try to see if, go ahead, please.
Just a recommendation, but the recommendation goes maybe half a century back, right? The world was sending a probe into the space, and we had the Voyager that went in, I think, 1977. At that point of time, they had the wisdom and foresight to put in hooks for things that they had never anticipated. And therefore, they put up mechanisms like, software update. When you cross a certain level, you see new challenges. And across the solar system, the software updates are happening. So a recommendation would be just to have that Voyager mindset. Know that the journey is long, but prepare to align, to pivot according to the rigors of the new journey. So just a recommendation there.
You want to comment anything on that, Professor Somitra? Or
One is when we want not to do anything other than this X thing, then as I mentioned already, your system should be only engineered for that thing. But the second direction is when we want to achieve not just X, but X, Y, Z, then surely we must be prepared for these kind of updates.
Greetings, panelists. My question is for Professor Nilesh Mehta, sir. As we are talking about next generation communication, so we can see the rapid growth in both 6G and Wi-Fi communication. So do we have a slight possibility that in near future we can see both of these technologies coming together and working as one? And the second thing is, do we have a possibility of cognitive Wi-Fi in which they can sense, learn, and adapt on its own? And the last one would be, in the near future, what do you think would be the most important parameter to define something as like it's working properly? Would it be speed or spectrum innovation, or would it be intelligence of networks, or would it be both? Thank you.
Okay,
I got the chance. I've been trying to raise my hand for a really long time.
Okay, so yeah, so first thing, the first question, if I can summarize it right, was, do you see Wi-Fi and 6G becoming essentially a single wireless system? The answer is no. There's a reason why there are different wireless systems. So the wireless channel is in general a very difficult channel to operate over. You've got to ensure coverage, you've got to ensure energy efficiency, you've got data rates, you've got whatever else. So given the various design parameters you have, each system targets a different thing. So Wi-Fi is targeting primarily indoor, cellular is primarily coverage with mobility, Bluetooth is low energy with sensing, and so on. So I don't think they'll ever merge. The cost points are also vastly different. Of course, they will borrow each other's technologies. The fundamental technologies will show up in different ways. That's there. But but you'll of course have, your phone has all of it. So that's the way it'll work. Second question was what? Sorry. I don't know. I do know that Wi-Fi sensing is a very, very serious application. In fact, there are already products out there from what I understand. So using, what I mean by Wi-Fi sensing is you've got access points lined up. Now, can you together, based on that, figure out, for example, have I had a fall? So those things are already being, there are already prototypes out there, and probably even more. So to that extent, yes. The word cognition has a very broad meaning, right? So it's hard to say what do you mean by cognitive. So for example, if you told me what is a cognitive wireless system, the answer would have been, depending on the availability of the spectrum, I would grab the spectrum, let it go if somebody else comes, and so on. Would Wi-Fi do it? It's already in the unlicensed band. So it's already grab and go, take or leave. So to that extent, it's already in a way interference resilient. But would it grab new spectrum? I doubt it, because it's already unlicensed. But cellular would certainly come into Wi-Fi, grab it and go back. That's what's called LTE unlicensed. 5G also has a version of that. That can happen. Beyond cognitive, I don't know. And what is the third one? Intelligence is a way to an end. I think the end is, as a customer, I couldn't care less how smart the network was, so long as I got my data rates and my coverage. So I think it depends on what your application is. So if you're trying to do, file transfers, then all you care about is best effort traffic. But if you're trying to do, a control loop in an industry 4.0, you couldn't care less about data rates. What you want is latency guarantees, and if I send a control packet, that packet has to reach me with a 99.99% reliability. So it's a very application specific answer you get. Right now, most of wireless, despite all the claims, is essentially best effort data with higher and higher data rates. But going forward, I think wireless is going to be much more what they call QoS sensitive, quality of service sensitive. Different QoS requirements will have very different solutions.
So one more question.
So this is not a question, but just a curiosity, like with so many AI centers across, is there a national effort of a of the data that we collect, so that we have some kind of data repository which people can use, some clean data, some noisy data, and maybe we can have something like a data dan initiative where everybody who works in data gives some data to the repository. And because I'll tell you, I come from speech, and when I was used to be a young speech researcher, I used to feel that making data, making different types of data was a very, it wasn't a job for a scientist. But today I stand so much corrected. I was so wrong. Whereas NIST coming up with the kind of data standards that they have, we are still looking for data from China, data from somewhere. So I think that initiative of data repositories and good kind of the filtering, the clean, the noisy, all type of data repositories, I think we must. I think maybe they are there, I'm not aware of it, but maybe your comments on that.
Any panelist? Professor Nishal Verma. Maybe panelists can answer that and we can go back.
Yes, you are very right. You see, at present, we do not have any central repository for data. So data are there, but it's all distributed, and that too, it is difficult to believe on the data that we are either downloading from India or anywhere else. So that is really a recommendation. I think we should include in the recommendation that there is a need to create a standard data set. And when we are talking about the processing and all, that's fine. I mean, when we have the data set, at least we can believe on that this data set is genuine, and then we can further work on it to process it. So I think I would also like to include this in the recommendation. It's a very important point, actually. Without data sets, it's impossible to develop the better AI models. Absolutely. Especially, you see, in biomedical area, we are lacking very much with the data. Even US is also very much lacking. So I was working with the University of Tennessee. Then I found while figuring out the genes that are responsible for the cancer. Nowadays we are a little bit up, but not up to that much where we can have the complete data set. So data is the data collection, data center. Our own data center will really help us in AI development for Indian systems. Thank you.
See, data cannot be having at one place, one center. There is a lot of awareness now. See, for example, just 5 years back, you could not get the IMD data from anyone. But today, this is opening. In fact, India Meteorology Department has got much better data than anywhere in the world. For last 120 years, we have got full data. So that's one part. You can get it from there. Geophysical data. Today, NGRI is opening itself. They have got an enormous amount of data they were not giving to anyone else, but now they are giving. So you depend on what? Suppose you are looking for a satellite data for various instruments. It's open today. Only thing you have to register. You have to register if you are looking for in space, there is a possibility. What kind of data you want? You want data on astronomy, you want data on agriculture, you want data. So all the data is available. Only thing you have to really show your interest in that and also say that you have got such interest. So it's impossible to have a one place. But today, countries opening up for various kind of data. There's a very cautious approach on that. Actually, it took a lot of effort for me to open the data in IMD. Similarly, now they're also opening to a large extent the data from the related to what we call it, something like segment where you want to have geophysical data. So even those departments are opening. So you have to really see, go to the concerned department, then you can get the context.
Go ahead, go ahead.
I'll add one more thing to it before we go
Yeah,
back
yeah, go
to
ahead,
the next
Professor.
person. So when we talk about data sharing, now we have a new DPDP Act. So if there is a personally identifiable data, PII, then we have to be very, very careful. And then we also have to give rights to the person whose data came to delete the data. So there are now other kind of responsibilities also coming in. At IIT Kanpur, we are already discussing this at a institutional level, but presumably this will happen. And sometimes when you think that the data has been robbed of this PII information, that no person can be identified, it can surprisingly still be there. To give you an example of what really happened, Netflix wanted to have a better movie recommendation system. So they removed the user's data. They just numbered some roll number like 1, 2, 3, 4, 5 and the movie recommendation data, and they put it online. The hope was that people, machine learning people will analyze this data and come up with better recommendation algorithms. What somebody did is that they realized, well, if somebody is watching a war kind of movies and he is watching this on, he or she is watching it on Netflix, might be that same person is also giving recommendations or comments on publicly available data sets like IMDb. So somebody simply correlated and they found out who the person is to a major extent. Similar kind of things have already happened against Yahoo, against other agencies also. So even if you remove, you think that their personal information has been removed, sometimes it can be very dangerous. So it has to be very careful in sharing the data.
Thank you. Thank you very much. A very interesting, very, very interesting point. Let's go ahead, please.
Hello, sir. My question is for Nishal, sir. So myself is Shubhranshu. My name is Shubhranshu. I'm a third year student in BTech CSC in AIML from Galgotias University, Greater Noida. So my question is related to my experience in what I'm studying. The subjects that I'm studying right now is deep learning, machine learning, and data science. But sir, the algorithms that we are taught, the way we are taught, but the outcomes that we are seeing, like recently Claude 4.5 came out, I'm not able to relate what I'm studying and the pace at what AI is moving forward in the industrial application. So, sir, what should be my approach, or how is there any changes according to you?
Okay, thanks, Subhranshu. So once again, the question comes: what courses have you done on AI? Is there any course that you have
Sir,
gone
apart
through?
from academic?
Formal course in your BTech. Have you
Uh,
done any course on AI?
Yes, sir. This is my fifth semester.
Okay.
And now we are introduced subjects like deep learning and machine learning.
No, directly deep learning will not help,
Sir,
right? Unless we understand, right, what AI is, number one. Number two, on what basis the models are. Like whatever, intelligent agents that we follow for developing AI models, like a very popular basis is artificial neural network.
Yes.
The fuzzy systems, genetic algorithms. So like that, so unless we go through these subjects thoroughly, any of these, it will be very difficult for us to understand the, real AI. Because most of the students, what I have seen doing, they are just, calling the function, right, ANN, or maybe the deep learning function in either Python or MATLAB, and they are taking some data from anywhere, and
Yes,
then
sir.
they claim that they have
Made a model.
right. So that is what is not the right way to proceed. So my suggestion would be to first go through these courses if you really want to learn AI,
Yes, sir.
right?
Sir, because I'm not able to relate myself that why am I studying this?
Yeah, then you will be able to understand.
Yes. Thank you, sir.
Thank you very much.
Afternoon, everyone. My question is from Dr. Kamath. That, sir, from your experience, what do you think about the next generation UAVs that can have the abilities to be amphibious one? What do you think about that idea, sir?
No, see, obviously there are, especially with drone technology, ultimately the use cases are up to your imagination, right? So I think almost any use case you can use a drone. So I wouldn't want to, so amphibious drones are also a very important or very interesting use case. And I'm sure it would have its application. So I'm not sure what your question is, but it's certainly an interesting idea.
So much, sir.
Already that about that where the data is available, not only personal or biomedical data, but I know that Dr. Somnath was here. ISRO gives the data now. That I was telling, and lot of authentic data now. Since lot of data, I have taken and they give. That's why I'm telling that if we
Thank
can
you.
contact, they have procedure.
Thank you.
And with satellite data, they give.
Noted, noted, ma'am.
For
Thank you.
research.
Thank you very much. Let's go to the, let's take two last questions, right? One of the students and one more question and then we'll wrap.
Good afternoon, sir. My question is from Professor Nilesh Mehta, sir. Sir, we are currently working on wireless communication systems. So my simple question is, can we integrate RIS into Wi-Fi 6 or upcoming versions?
Very specific. Where did you hear about RIS?
So, sir, I was in IT Patna, sir.
Oh, very
There
good.
was symposium on 6G.
Oh, very good,
Sir.
very good. Professor Pritam Kumar.
No,
Not
okay.
Professor Pritam
No.
Kumar. Who organized the symposium?
So Dr. Amit Kumar, sir.
Amit Kumar.
Department of Electrical Engineering.
Very good. Go ahead.
So the question was, can you integrate reconfigurable intelligent surfaces into
Sure, sir.
Wi-Fi 6 or beyond? In principle, yes. However, there's no standard support right now. Like Wi-Fi 6 doesn't even know RIS exists. Wi-Fi 7 doesn't know. Wi-Fi 8 also doesn't know. So if you have a non-standard specific solution which doesn't affect the standard, like somehow it does its own thing without modifying the standard, you can.
Yes, sir.
If it's a standard modification, then you've kind of got to build it into the standard. So you're looking at Wi-Fi 9, you've got to push that in and then it would be part. But in principle, RIS makes sense for Wi-Fi. Yes, it does make sense.
Thank you, sir.
Is it? So very good, because this is in my area. Maybe I can also seek a clarification as I elaborate. So because primarily RIS is for range extension and coverage, right? Because that is primarily for outdoors. But do you think there's a requirement? I mean, because Wi-Fi already with access points and with increasing density, the distances are very small. So do you think RSI would bring any additional benefits, or is there, do you think envision any scenarios where RIS is really needed in these kind of situations?
So to me, actually, I think RIS will have more impact in the indoor than the outdoor.
Is it? I see.
The reason being, for example, I mean, I am talking to you, there's a wall in the middle.
Okay, the blockage and all
so
those.
then the RIS will give me an alternate route. It's essentially a mirror that can be configured. So I think, and the world is too big a place for a tiny little RIS to make much of a difference. But indoor, you've got possibilities for a lot of.
Very good. Excellent. Thank you. Thanks for that very specific and interesting question, I guess. So we'll take, I know there are a lot of interesting questions. I think we'll take one last question from this gentleman over here, and then we'll wrap up. Is there any question on cyber security? I think just to balance, because a lot of questions on AI, some questions on 6G, drone. Maybe we can wrap up with a question on cyber security, if there is a question on cyber security. Anyone has a question on cyber security? You have a question on cyber security? Sir, everyone wants to ask AI data science. Your AI or 6G? What is your question?
So my question from Nilesh sir. Sir, previous lecture talking about the Wi-Fi generation 6G. So sir, if I am talking about the medical lines, so sir, can be possible enhance Wi-Fi range because the some critical situation or other patients because the some medicals due to some that like that heart patients and and not be provided the medicine for those times. So nearly medicals and nearly hospitals can be contact for those time, and can be and heals can will be get heals from the patients.
Okay, so let me summarize the question. You're asking, can I use Wi-Fi or 6G? They're different. For enabling a person to reach a hospital, patient to communicate to the hospital. In principle, yes. I mean, all these technologies are giving you a data pipes, or like voice calls. So, so long as you have coverage, it'll do it. Now, do you have coverage? It's terrible, honestly. So, I think coverage is one of the goals that we want to improve.
I think, are you saying something a little bit more specific, like medical devices communicating with the hospital, something like a band or a pacemaker or some kind of a medical device that automatically communicates with the hospital, informs the person is...
Automation is one.
In emergency, hopefully. Yeah, something of that sort.
I don't know the answer, honestly. So people in the industry would know. I don't know. I don't know if there are such solutions.
Sir, in small IoT devices can be added this Wi-Fi technology.
No, you don't want Wi-Fi in IoT. Your battery will die in a day. You don't want Wi-Fi in a small IoT pacemaker. It's nowhere close to the energy efficiency you need for that. There's other technologies.
So thank you very much. I just have one last question because of cyber. I want to ask something on cyber security specifically, which is we hear a lot about quantum computers, quantum algorithms, etc. What do you think is the role of this? What do you think will start happening when you have this quantum computers and quantum attacks on cyber security? Can you elaborate a little bit on that?
Yeah. Okay. So first is from a practical point of view. For last 20 years, I've been hearing that quantum computer is coming in next 5 years. Okay. So and probably this will happen for next 20 years also, because we don't have the practical technology as of today. So that is the practical side. We may not need to worry about it. But from the pragmatic point of view and from a long-term point of view, we need to understand what happens actually if there is a big quantum computer which can actually break crypto systems and these algorithms, solve lots of these hard problems and so on, which actually theoretically can be shown to be done. Like you can break the AES 128 in just 2 to the power 64 calls to the compression function, to the encryption function of AES. So if things like this start happening, then we'll have to be afraid. As I mentioned already, it is not likely very soon, but suppose it happens, then we are already prepared. So there are mathematical problems which are known to be not solvable in quantum polynomial time. And these are the kind of problems which cryptographers have already been studying. There is a big mathematics history theory behind it from last few hundred years. In particular, there are certain problems on lattices. And that's why I was mentioning abstract algebra is extremely important. If you want to enter into cryptography, abstract algebra is absolutely important. So there are number theory and abstract algebra problems which are not solvable. Provably, you can show that even if there is a quantum computer, it will not be able to solve them in polynomial time. And therefore, we will remain quantum secure. And this entire direction is called PQC, or post-quantum cryptography. NIST is already standardizing certain algorithms of PQC. They have already standardized for encryptions, and they are currently working on standardizing for signatures. We have a colleague here, Dr. Anshuman Karmakar in Computer Science Department, who is involved in one of those signature schemes design. So we have expertise in IIT Kanpur in this domain. We also have expertise in implementation of these in hardware. Ultimately, we will need these algorithms to be implemented. So we have a few people in CS, we have a few people in electrical. I myself work on that area. So we have people who are actually looking at implementation also. And the current protocols don't even support these because of the size restrictions, the size modifications, the data size, the packet size will change and so on. So there is some work which I am doing with Anshuman on modifying these protocols or ensuring that these algorithms can fit into the existing protocols. So a lot of work is happening in this practically. Thank you.
Go ahead. It's not working. Is it microphone?
Quantum cryptography.
Building a post-quantum cryptography system, it had better be justifiable without the quantum computer.
Thank you very much. So on that note, I think we are exceeded our time, allotted time, and it was a wonderful panel discussion with a lot of interesting questions. So thank you very much. First, thanks to all the panelists, Professor Nilesh Mehta, Professor Nishal Verma, Professor G.M. Kamath, Professor Soumitra Sanadia. Thank you very much for your patience for first summarizing and also taking all the questions from the audience as well as, of course, everyone. And thanks also to the audience for the enthusiastic participation and the wonderful questions. So thank you. We'll break for lunch and we will meet again. So, 2 So next session starts at 2. So 2 to 3:30 is a valedictory session in the same room. So please join us for the valedictory session. Thank you. Thanks very much. Thank you so much.
On behalf of Mr. J.D. Patil, President, Indian National Academy of Engineering, and Professor Manindra Agarwal, Director, IT Kanpur, the co-chairs of the conclave, we extend a warm welcome to all of you at this valedictory session of the Engineers Conclave 2025, organized in association with IT Kanpur. Over the past 2 days, we have witnessed remarkable deliberations, thought-provoking discussions, and inspiring ideas from some of the finest minds in engineering and technology. As we draw this enriching conclave to a close, it's a time to reflect on our collective learning, express our gratitude, and look ahead with renewed enthusiasm. I would now request Mr. J.D. Patil, President INAE, co-chair of the conclave, to kindly take his seat on the dais. I would now humbly request Professor Aditya K. Jagannatham, ID Kanpur Faculty ID Kanpur, coordinator of Theme 1, Intelligence System, to kindly step forward and be seated on the dais. Requesting Professor Santanu Chaudhary, Vice President INAE, coordinator of Theme 2, Interdisciplinary Cyber-Physical System, to join us on the dais. Professor Jagannatham. I now humbly request Professor Nishal Verma, convener of the Engineers Conclave 2025, to kindly step forward and be seated in the dais. I would now humbly request Dr. P.S. Goel, FNAE, former President INAE, and Chairman, valedictory session, to kindly come forward and be seated in the dais. Ladies and gentlemen, please give a big round of applause for all our dignitaries. To begin with the proceedings of this valedictory session, may I now invite Mr. J.D. Patil, President INAE, to give the introductory remarks.
Engineers conclaves, to my mind, have always been a very learning kind of experience. There are few domains one knows of, but to sort of bring in the breadth and the depth across what all we discuss, and each of those engineering conclaves in the past actually have brought in different subjects, and that's essentially where what INAE does, we actually pick up those inputs. When we start talking of this particular EC, we see that there's two themes on which we debated. And if I have to sort of look at beyond those smart and the intelligent systems and the cyber physical systems, if I go into little next level of discussions, there's lot in terms of individual sessions which has gone in the domain of call it data, call it AI, call it smart systems, call it intelligent systems, or for that matter drones, or varieties of aerospace and related areas, and cybersecurity. Now, each and every of those, we had some amount of discussions in the previous session in collating those inputs that will go to INAE, and those coordinators for those two themes are here right on the dais. Those who were present in this hall have seen the kind of active interest the presidency of INAE takes, and Dr. Goel was here all through, and a lot of you would have seen that the kind of deeper thinking which people bring in, besides of course those who speak and do the needful. So this session is all about what we have really learned and what are those specific few things which we'll take away. And of course, if anything is missed out, now that this is everybody together, those two sessions now have merged. If there's anything that comes up, we'll do that part. With that, let me say thank you very much. Thank you, IIT Kanpur, for hosting all of us here. And of course, look forward to doing series of subsequent major programs at IIT Kanpur. Thank you so much. Jai Hind.
Thank you, sir. I would now request Professor Aditya K. Jagannatham, coordinator of Theme 1, to kindly present the summary of technical session on intelligence systems.
Would you prefer to sit down or you would prefer to sit here only? It's okay, right? It's okay. वो वाला कॉलर वाला माइक दे हाँ हाँ वहाँ पे वो लेपन
So I think I'll take about 20 minutes. Take. So thank you very much, the dignitaries.
Not focus on discussion.
Yeah.
Only on recommendations.
The recommendations from the these things, right? Yeah, definitely. So Dr. Goel, Dr. Patel, Professor Nishal Verma, Professor Santanu Chaudhary, Head of the Department, Professor Yogesh Chauhan, for giving me this opportunity, and all my colleagues who are Professor Jalil Akhtar, Professor Patel, Professor Raghavendra, and Professor Nagarjuna, and Professor Ganeriwala. I think all of my colleagues over here who have helped me on this conclave. So thank you very much. And so I'm going to be summarizing theme 1. So theme 1 comprised of, as you know, I think we had a discussion. I think most of you have been here, also comprised of 4 sessions. I think very interesting. Really, the theme was intelligent systems and brought together next generation communication networks, AI and data science, of course, drone technology, and cyber security, each of which is a vast field by itself. And of course, I am not an expert on any of them. My area is wireless communication, so I can talk a little bit about the first one. And I'll try to summarize the recommendations, etc., to the best possible extent in all of these areas. But if I misspeak or if there are any errors, I think many of the speakers are sitting here, so please feel to correct me, and so also the session chairs. So with that disclaimer, let me go on to, as I said, there are these are the 4 different sessions: next generation communication networks. What are the challenges and directions for future 6G? I think in communication, when you talk about the next thing on the horizon, the big thing on the horizon is very clear, that is 6G. And of course, with due respect to our other speaker, Professor Nilesh Mehta, was also highlighted that don't forget about Wi-Fi, right? So Wi-Fi is not lagging behind. So 6G and Wi-Fi, it's going to be a very interesting. So I think one of the recommendations that has come in terms of this session is that we have to take Wi-Fi seriously. That is, while we are focusing a lot on 6G, 6G might seem something like a game changer, and there's a lot of buzz around 6G. I think probably Wi-Fi is also not to be left behind. I think that's the overall policy recommendation. I think AI and data science, there are a lot of interesting recommendations. I think Professor Amrutur Bharadwaj, Professor Sangamitra Bandyopadhyay, and Professor Subrata Rakshit. I think what is very interesting is, if we start from the last one, Dr. Subrata Rakshit is staying over here. It's called for new levels or new modalities for standardization, ensuring reliability, because we have dealt with conventional engineering, we have dealt with software engineering. Now is the time to deal with AI, how to ensure standardization, calibration, reliability of AI. And from that perspective, and of course, Professor Amrutu Bharadwaj talked about engineering assistants and how these can enhance engineering education. You have biomedical applications by Professor Sangamitra. Coming next to drone technology, of course, we have the session chair, Professor Nishal Verma, and he had also summarized in our panel discussion. I think there is I think one of the key aspects of this session was that, of course, drone technology is going to be very important both for civilian and military applications. And I think Professor Dr. Somnath also participated very actively in that session. I think one of his key recommendations was also that we have to develop an entire drone ecosystem. That is, when you think about a drone, it's not just the drone, but there's a drone. The drone has a lot of, it has navigation, it has sensors, it has a large number of systems and subsystems. So there has to be an entire ecosystem. There has an entire set of products which have to be manufactured in India to support this drone ecosystem. I'm not sure if I'm summarizing correctly, but I think that was one of the suggestions that has come from it. But it was very heartening to see, of course, there were two speakers from TSL and there was one speaker from National Aerospace Laboratory. So it's very heartening to see all the developments that are taking up, that are coming forth on drone development and what are the possibilities and the potential. And of course, cyber security, of course, we have the session chair, Professor Soumitra Sanadia, and it's not my area, so I'll just try to summarize it to the best possible. But there's a lot of applications for as we go into more and more connected world and more either intelligent or connected, or as we venture more into the cyberspace, be it either in automotive, be it either healthcare, or be it either in so many different areas. So a lot of interesting aspects of cybersecurity, for instance, cybersecurity for recommendations of cybersecurity for medical devices, policies of cybersecurity. There's an intense need to develop policies for cybersecurity and also for cybersecurity for automotive. I think that was what was brought in the last talk. So let me just go a little bit again into each of these things. I think the first talk highlighted the importance of 6G, right? And how 6G is on the horizon. What are the different applications for 6G, be it either near zero latency or digital twins, mission critical applications, and so on and so forth, right? And therefore it is essential, I think the recommendations here are to develop unified and practical architectures, all right? Also integrate AI and ML capabilities with 6G. I think the other important recommendation that we are using the FR1, FR2 bands. FR1, of course, is a conventional sub 6 gigahertz, and we have the FR2. I think some of you might not come from a communication background. So just tell you a little bit about that. FR1 is the conventional, what we call as the 6 gigahertz and lower band, and FR2 is the 25 megahertz. And I think the new band that is coming up, or that has been recommended, is FR3, which is around the 7 gigahertz. I think that strikes a balance between the 25 gigahertz and the sub 6 gigahertz. I think if you go to the higher frequencies, the power losses, etc., are very higher, and if you go to the lower frequencies, of course, the bandwidth is limited. So I think the 7 gigahertz, the FR3 band is acts as a very good alternative, solves both of these problems, and of course providing very high bandwidth coverage with very low losses, right? So I think that's one of the important recommendations, that is to focus on newer bands, that is F3, and of course also not to forget our classical technologies, that is of course what was fairly recent, but now the way technology is evolving, that is our massive MIMO and meter wave, etc. And the other recommendation here is to align ourselves with the standardized bodies, for instance, your 3GPP and ITU, etc., and of course, close collaboration between academia and industry. I think that's a theme of that is better need for improved collaboration between academia and industry to take these to the next level. Focus specifically a little bit more on federated learning. I think session.
So when we talk about AI and ML, AI, ML, and to what extent AI, ML can be used in wireless technology development. So I think this was an excellent talk, which sort of spanned both the areas, AI, ML, as well as wireless technology. So federated learning, I think, is one of the areas where which can be used in this is a paradigm where devices can train collaboratively without sharing data. So you can have a base station, you can have a mobile station. I think you can train them with minimal exchange of information without exchanging all the data. So I think that is a very interesting perspective. So this is that these AI and the 6G and IoT networks need federated learning to enhance their capabilities for defense, smart cities, and other applications. And there are some hurdles in that, for instance, such as non-IID data and device heterogeneity and etc. and so on and so forth. So these need to be overcome to incorporate federated learning in the next generation communication systems. And also there has to be security again, which again ties into probably our last session, that is how do you talk about the security, differential privacy, blockchain style verification for our next generation systems. And also it talked about multi-tier federated learning architectures and defense academia prototyping to help deliver these federated learning algorithms in 6G. So the next talk, I think that is where I was talking about. The next talk was very interesting in the sense it moved away from our conventional understanding of wireless technology or connectivity being focused entirely on, for instance, our with different generations of 4G, 5G, and 6G. But what we are realizing is that dominant fraction of the connectivity in today's world also comes from our Wi-Fi, right? So the idea is, the Wi-Fi can be a core 6G access pillar, so that can complement cellular. Like the speaker emphasized that cellular is for outdoor and coverage, while Wi-Fi is for indoor connectivity, and it can take offload a lot of the pressure on your outdoor network. So there is a strong need for Wi-Fi evolution as the generation of cellular networks evolves. And also talked about the different technologies, for instance, the different access technologies, OFDMA, MU, MIMO, etc. And Wi-Fi 7, which is one of the things that is multi-link, and also the 4096 QAM, which is basically a high bitrate constellation that significantly increase your data rates because you're transmitting a large number of bits per symbol. So I think that is another interesting recommendation. And another very interesting recommendation that has come up from this is the full duplet technology, which is I think some of you I think again there are many students, so some of you might realize we have what is called conventionally half duplet technology, right? A half duplet, and then you have either time division duplet, that is if the base station is transmitting the mobile in one time slot, then the mobile is transmitting to the base station another time slot, or we have frequency division duplet. Now full duplet is a new technology where both the base station and the mobile can transmit to each other simultaneously, and that is an interesting thing that is catching a lot of traction. And there is a lot of course, the only challenge in that is self-interference. And it's interesting that this full duplet thing has come up, and whenever this full duplet has comes up, I cannot help but mention IIT Kanpur, because I think Professor Nilesh Mehta also knows the IIT Kanpur is the genesis of this full duplet technology, because the full duplet technology, I don't know if people have heard it, the first proof of concept or proof of action of this full duplet technology was provided by Dinesh Baradia, who is now professor at University of California, San Diego. And in fact, he was a BTech project student of Professor Ajit Chaturvedi, who was the session chair yesterday. So that is very interesting. And he's going to be here, interestingly, he's going to be here this weekend because he's been given a Distinguished Young Alumnus Award by IIT Kanpur. So that is another interesting thing. So he's going to be, whether full duplet technology is going to come or not, he's going to come over here this weekend. So that is something that is very interesting. So I think IIT Kanpur has a lot to do with some of these technologies, right? So that, of course, you can see that in my area, I have definitely a lot more knowledge. So in the other areas, let me try to see AI data science. Of course, Professor Nishal Verma is an expert over here. I'm standing in front of him, so I'm a little bit nervous. Hope he does not mind if I make some errors. So of course, Professor Santanu Chaudhary is also here, not to make any, I hope I do not make any mistakes. So we have, I think one of the key recommendations here is Professor Amrutur Bharadwaj from IISc. I think very interesting recommendation is that the term I would like to carry out from his talk, of course, AI and data, AI ML, the first talk, the plenary talk by Professor PPC, I think that was very eye-opening, excellent, exceptionally good. And I think after that, I think most of us are now familiar to a large extent what AML is about, what AI ML is about, and what the challenges. Right. I think one of the interesting things that has come up in Professor Amrutur Bharadwaj's talk especially is the concept of intelligence as a commodity, right? And that was very interesting. I've never seen that kind of thought process about intelligence before. So there are a lot of commodities that we've had. There are a lot of commodities, like bandwidth became a commodity maybe about 10-15 years ago, but now intelligence as a commodity. So can you go to market and buy some intelligence? What are the units going to be? How are you going to buy this intelligence? So that's a very, very interesting thing. And I think that can be a very good tagline for our future AI and development, unless he has patented it, I'm sure. I'm not sure if he has patented it. If it's not, I think we better patent it soon. So can intelligence be a commodity in the sense that can intelligence be bought on demand to handle these different tasks? And in particular, I think he had talked about two different applications. One is, yes. So I think that is one of his recommendations. That is, this intelligence as a commodity can use, for instance, as an engineering application. That is, can this powered AI powered assistants be used for engineering applications, right? Can you use these um, can you use these assistants, or can you have these assistants which can now help us in these engineering applications? That is one. And the other is this AI based teaching assistant. So can these teaching assistants may now be developed and now can be probably procured and help significantly in our engineering education. So that is another interesting recommendation that has come up. And then the other one is, of course, develop a sovereign engineering AI framework. There's a framework that is specifically suited for the needs of our country, the needs, be it other the teaching needs, be it the engineering needs of our country, and etc. Let us look at the next aspect. The next aspect is biomedical research using artificial intelligence. For instance, it talked about the evolution of AI and GPU enabled and very different aspects of AI, such as your graph learning applications, etc., and so on and so forth. For instance, I think the speaker talked about several applications / recommendations. For instance, single cell RNA sequencing, multi-objective AI, etc. And I think one of the recommendations here, or the emphasis here, was about India's priority to build these indigenous biomedical data sets. All right. So this is that can form an EHR backbone and probably AI ready health cards. I think there also talk on developing a card similar to your Aadhaar card or something that can, a particular number that can hold the entire health record of a particular person, and that can be integrated with various AI tools, etc. Right. So there's again another need. I think also advocated community level personalized medicine solutions, and also scalability, affordability, and also a clinician AI policy collaboration. What is a policy? Development of policies for clinicians to collaborate, or clinicians to use AI probability to ensure the highest quality, to ensure fairness, data quality, and research in medical AI in India. The third speaker was Dr. Subrata Rakshit, and of course his recommendation was very clear. That is basically it is a design paradigm, and of course we have talked about, as I told you, there's conventional engineering design, there is software design, and now we are looking at design, AI design. So there is a need to develop urgent calibration standards, right? Requirements for development certification, labeled data sets, adequacy criteria, risk and model design. And also there has to be operational calibration data sets. So the urgent need to develop data sets for calibration of these, you call it either AI assistants or AI models, etc. And of course, believability matrix, familiarity, competence, I think these are, and also I think finally recommended a calibration and certification framework that yields transparency and believability scores without, of course, exposing the IP of these companies, right? So this distinguishes this, and there's a this significantly distinguishes it from the classical software as well as your classical engineering type development. So I think there is an immense need to develop this calibration and certification metrics, or you can say frameworks, etc. So we move on to the next session. That is, the next session was on drone technology, another very interesting area that was chaired by Professor G.M. Kamath, head of the aerospace department. Of course, the participants were Professor A.K. Ghosh and others. So one of the interesting things here was, first of all, it highlighted the indigenous UAV journey, how it began from a laboratory, or began from the airstrip of IIT Kanpur and reached to a startup which was finally acquired by Tata Systems. And I think the recommendations here were very clear. The recommendations here were the future dominance in AI, dominance in drone technologies naturally hinges on AI, communication, and energy efficiency. So each of these, there were a set of recommendations of what are the technologies that need to be that need to develop to enhance AI and drone technology, communication for drones, and also energy efficient propulsion. So it called for, of course, again, I think there's an underlying theme, and it's an underlying sense that goes through all the themes, that there really is a need for increased collaboration between academia, startup, and these defense pipelines. All right. And also the speaker recommended a national mission to integrate R&D certification and rapid deployment of UAVs and counter UAVs. The next talk was Mr. Prashant Badoria from TSL. I think he talked about the various kind of drones, the various capabilities. For instance, what is the difference? There's a drone, different drones with have different capabilities, such as 24-hour endurance, 30,000 feet, and etc. 2250 to 300 kg, etc. And I think what this Dr. Prashant, Mr. Prashant was specifically focused on is certification for airborne software and an export interest in light manned ISR variant. And of course, again, there was a heavy emphasis on end-to-end Indianization, that is, be it either mission computers, high-value sensors, etc., or standardizing the AI and data fusion components for drones, and acceleration of this certification to meet the demands for the development of drone technology. And of course, the last talk was by Dr. Pashelkar, who was the director of the National NAL Bangalore. And I think one of his main key takeaways was how NAL can serve as to aid significantly in the development of drone technology, either for testing of drones, either for certification of drones, or either for serving as an aggregator for different kinds of drone components, etc. So I think there's a sense that the drone era is underway, and especially there's highlighting the NAL's high altitude pseudo satellites, etc. And reported also 1/3 or 1/3 scale prototype with full scale stratospheric vehicle, etc. And the talk specifically outlined shifts to swarms and multi-sensor fusion, pilot associate stack, and so on and so forth. And it also emphasized the need for AI in flight control and limited, well-trained envelopes with limited in reasoning, etc. And certification with human in loops design, etc. And how NAL essentially can act as a hub for the development of everything related to drone technology, be it either certification, testing, etc., and so on and so forth in India. And for that matter, of course, IIT Kanpur also offers itself as a hub for the development of drone technology with the various facilities, be it either your wind tunnel facility or your airstrip or so on with respect to payloads and so on and so forth. So I think there's a lot of interest in drones, and definitely there are a lot of hubs, and there's a need to develop more hubs for development of drones, be it either calibration, testing, etc. So these are some interesting policy recommendations. We come to the next session. That is, the next session is on cyber security. So the cyber security, I think there was also again a lot of interesting discussions happened over here and a lot of interesting recommendations. And so I think the first talk specifically focused on basically cyber security and cyber security applications and cyber security for medical devices. So there was essentially a need to push heavy security and lightweight authenticated encryption specifically for medical devices. I think there is identified several urgent R&D needs, including, I think, optimized message formats, energy aware lightweight crypto algorithms, FPGA prototypes, rigorous test and verification, including a regulatory gap in India, and also the need for a new regulatory framework probably in India specifically with respect to cyber security in medical devices. The second talk by Ms. Kamini Malhotra, I think that the key recommendation here was to develop a set of policies for security, be it either for data provenance, that is to track where the data is originated, where data is being transferred, context-aware segmentation, formal methods in change control, be it either with respect to firewalls, SDN, etc., and continuously scan for conflicts, and also to engineer for disconnected or push policy caches and graceful degradation, etc. So I think there is a significant need to develop policies that meet the cybersecurity needs of today and the cybersecurity needs of the future. And coming to the last talk by Dr. Shashwat Raizada, I think the talk here focused predominantly on cybersecurity for automotive. I think that need here was also to develop a standard, unified security AI governance model and a standard that meets the cybersecurity needs, especially for vehicles and connected vehicles. I think so. There is modern vehicles are tightly coupled, and there are many external links, and making these these connectivity-driven vehicles are susceptible to attacks. Of course, right? There are a lot of links that make them susceptible to attacks. So there is a need for safe AI integration and ML-specific threat models and continuous verification, etc. And the speaker also recommended a compliance backbone with along the lines of ISO, SAE, and these different standards and preparedness for the EU CRA. I think that is, there are different global capability centers. So I think there's a need to also prepare for this European standards, etc.
I think also another important takeaway was the operational hardening, the secure boot and signed OTA rollback, etc., and least privilege gateways and protocol-aware IDs, etc. So ultimately, the final recommendation was a uniform safety, security, AI governance that makes some of these cybersecurity, I think cybersecurity development, be it other cybersecurity development or I would say next generation cybersecurity possible, especially in connected vehicles. So I think that gives us, that completes my talk. So I think in order to summarize overall, I think we had, I would say, very wonderful discussion, a very vibrant theme, intelligent systems, which brought together, I think, ideas, people, personalities, ideas from these different domains, be it either AIML, be it either next generation communication systems, be it either drones, cyber security. I think there's a lot of intelligent ideas, intelligent, interesting recommendations. And I would also say there's a lot of synergies between these different sessions that was brought together, and there were several recommendations, and we look forward to preparing, of course, along with Team 2, we look forward to preparing a detailed report. I think we already have several ideas, several recommendations, etc., summaries, and we look forward to preparing a detailed report, and the same report, I believe, will be available openly and will also be submitted to the appropriate authorities. With that, I would once again like to thank INAE for giving me this opportunity, everyone over here, Professor Yogesh Chauhan, head of the department, also one of the main organizers of this event. Thank you. Thank you very much, Professor Jitendra Bera, of course, and Professor Manindra Agarwal, our patron. So thank you very much, and thank you, audience, also for your patience, yesterday, today, attending all the sessions, participating actively, and keeping us engaged, being engaged. And of course, to our chief guest, Dr. Somnath, it's indeed a pleasure. It's a great honor. Thank you. Thank you very much. And thanks very much. I conclude with that. Thank you.
Thank you, sir. May I now request Professor Santanu Chaudhary, Vice President INAE, Coordinator of Theme 2, Interdisciplinary Cyber-Physical Systems, to kindly present the summary.
Thank you for this opportunity to present the summary of the track 2. I think in presence of Dr. Somnath and other dignitaries and the leadership of INAE, it's really a momentous occasion for me personally, at least. So I shall not provide the details of what happened in the sessions, but I shall try to, what we have done is an abstracted recommendation, and that's what I shall present. If you look at, this is the core definition of cyber-physical systems. I need not repeat it. But if you see the critical application domains covers energy, healthcare, robotics, mobility, industrial automation, agriculture, communication, transportation, defense, and security. So all these things together actually, if you see, represents a modern technology and industrial ecosystem. In fact, that's the significance of cyber-physical systems, and with respect to that, what are the kind of recommendations these discussions really lead to? So if you see, these are some sample of technologies that were discussed during the session. One was RF energy harvesting, which is interesting because RF energy is omnipresent. In fact, we don't realize, we talk about solar only, RF energy also omnipresent, and it also offers a technology challenge, how to utilize and exploit. Then there were a few of these sensors, because sensors that really enable me to sense the environment, sense parameters for health, and gets connected to the systems to actually create applications around it. So there was also an accessible neurotechnology talk, which was very interesting in the sense that even in remote places, when there are brain stimulation and brain care can be provided, so that's the kind of a objective that talk really presented. Then there was robotics, which is human-robo partnership. And in fact, that's possibly given the population dividend of the country. We may not look at robotics per se, but robotics to increase efficiency. Then Industry 4.0 and digital twin, which is actually transforming, in fact, industry as such. And we found a very nice presentation of from IIT Indore, how they had taken this up to transform MSME. In fact, today, if you look at MSME, is the backbone of Indian economy. And anything done for them actually can have a transformative impact. So how the cyber physical system can play a role that was talked about. Then agriculture as a cyber physical system and geospatial technologies was discussed later on, but where also it's very, very important is that we are talking about geo-AI. The geography and AI coming together, it's completely a new perspective which provides us in terms of the development in areas like agriculture, like mining, like geological resource exploitation. So these are some of these key findings that we had in the individual sessions. So overall, what was the big picture emerged? If you look at it even with the presentation, earlier presentation as well, today we are living in a connected world, 5G, 6G, wireless, as well as satellite communication, and with respect to which we talked about geospatial intelligence. Then we have sensors, both sensing biological, chemical, and physical parameters. And these sensors connected over internet, that's the IoT, and that is linked with mobility and everything put together. If you see, sensing IoT and then connecting it back to the system, it's a closed loop system. And that's the closed loop system is what is cyber physical system, from physical to cyber back to physical. So here the key point is, therefore the bigger picture actually, if you look into it, today where industry is moving in Industry 4.0, where actually the traceability of the product and the traceability of the processes and quality control of processes are becoming critical. And that's where your cyber physical system, that sensing, monitoring, and AI can really make a change. And that's what I was talking about, how it can change the MSME. The universal healthcare, this is actually a challenge in the country because someone in a remote hilly place actually may not have access to modern healthcare technology, but the population has to serve. And that's where your technology, that communication technology and sensing and actuation can actually make really a change. So agriculture and food sustainability I already touched upon. And another very important thing which emerged is preservation of our culture and history. And with reference to that, digital technology has a role to play. And that's something which we should not forget. So therefore, there are huge opportunities. We have identified the opportunities where possibly the future research should be focused. One opportunity is industry IoT and smart manufacturing with Industry 4.0 in place. Then smart cities and infrastructure, because in India, a large population is today city-centric. So catering to the city-centric population, improving the infrastructure of the city by introduction of technology and appropriate technology can have a transformative impact. Then therefore, healthcare and agriculture, the other two things I've already touched upon. And if you see defense and national security, the development of CPS technologies for autonomous systems, surveillance, and cyber defense to enhance national security capabilities is, I think, even with DRDO discussions, this was very apparent and clear. Energy sustainability. In fact, energy is all through whatever we are talking about, energy is a key point. And there are energy, and we have to develop sustainable eco-friendly solutions with a human in the loop. So we are talking about cyber physical system, but the whole discussions, the way the things went forward, we are actually moving towards cyber physical human system. Taking into account Indian context, we possibly should not talk about only automation, but to make things happen with human in the loop. Therefore, this appropriate technology, demand-driven, these are actually the issues of appropriate technology. It's not just a technology which is state-of-the-art, but appropriate technology with reference to Indian data and flexible technology which is adaptable to local situations and demands. So the whole perspective of technology development changes. And if you look at the cyber physical system and why, and with AI in place, these technologies really become adaptive and adaptable. I think that transformation is something very, very critical with respect to what we talked about today. So we need a non-conventional approach and innovation from unconventional technology spaces. This is the open area for the Indian scientific community really to get into and create an impact. So observations that if you see today, this AI brings intelligence and adaptability to cyber physical systems, and machine learning plays a key role in making the system smart. The technology trend shows a closer integration of AI and cyber physical systems. In fact, these technology in engineering conclave has actually highlighted this data and perfectly aligned to the requirement of this integration. Engineering application of AI is a major thing which is emerging, and that we cannot ignore without integrating AI into cyber physical systems. So another thing is return of investment. I think all we talk about, but the return of investment is something very, very important when you talk about technology development. So innovative design of product and systems with a system level thinking and addressing needs of the people is a way to exploit and explore new markets. Without that, the technology innovation will not really go anywhere. It will remain confined in the papers and the publications. The startup ecosystem and rejuvenating MSME is really important, and also important for the engineers to think about new business models. It's not only a management task, because engineering perspective gives a different indications and different objectives to look at the business. So this is something which actually engineering community should really be concerned with, that novelty in terms of business model is an open space which is integrated with the emerging technology. So therefore, deep-rooted objective and pursuit of research and technology targets and consistent investment is important required. The ever-increasing bureaucratic hurdles in executing research and translation projects came up number of times. This is something important, and this is a phrase I got one of the presenter, that master-slave relationship between funding agency and PI should be stopped. Okay, so this was, it resonated with my thoughts, and I thought I should indicate it here, because it's a more open forum to talk about this thing. The action point is greater and continued trust on mission mode technology development project on AI-based cyber physical system to exploit AI for people-centric engineering and social problems. And possibly, INAE can take an initiative to create a research-cum-innovation fund with contributions from government and industry, boost to industry, startup, academia, research organizations to get more engaged in this area. And getting engaged in this area is something very critical and important for India's economic and technology development and becoming a technology and economic superpower. Thank you.
Thank you, sir. I would now like to request Dr. P.S. Goel, FNAE and former President INAE and Chairman Valedictory Session, to kindly deliver the valedictory address. I'll just introduce him. Dr. Goel is the...
Good afternoon to you. Dr. Patil, my colleagues at the dais, and also very senior people from the front rows. Our chief guest of this function, Dr. Somnath, and students. You have heard gist of everything, and we have been hearing for the last 2 days. INAE Engineers Conclave is slightly different from other conferences. The concept is that we must be looking for the future and try to solve the problem before they appear. And this is one exercise in that direction. And I think we have largely succeeded in that direction. You have heard the recommendations. Only thing is we have to do a little sharpening. We have to really say what we want to tell, let's say, the Department of Science and Technology, what we want to say the biotechnology, what we want to the Agriculture Ministry, or what we want to the PMO, or maybe Education Minister, so that he can do to the education. So we have to segment it and make it actionable. That word actionable is very important. And I'm sure the INAE and our colleagues at IIT Kanpur will really put into that framework. Now, engineers are important. Do you agree? I never felt so till I visited Netherlands. There was a conference, and actually it is a body of CASE, body of academies of engineering of the whole world, 28 of them. The mayor of Amsterdam in the evening, he came and he asked us a question. He said, I'm laying down the pipeline for drainage for Amsterdam.
it should last for 50 years. Can you tell me, what will happen in 50 years with respect to climate change so that I don't have to change in between this drainage line? It should serve for 50 years. And I was wondering that in our country, we don't even plan for today, we plan for yesterday. And he's planning for 50 years later. But then simultaneously he said he has got very high respect for engineers. And he said that Netherlands exists because of engineers. The airport in Amsterdam is actually 100 feet below the sea level. And there, first time I felt that, look, this is what engineers should earn. And this is where we felt that we should really bring INAE to this level. You know, we have 3 science academies in the country. We have many other bodies for agriculture, for metallurgy, for medicine and all that. INAE has to be different. And the main difference of INAE was that we should serve the society and give the solution before they occur. And this is one exercise in that direction. I have been visiting the government of India, particularly Modiji's government, for last 10, 11 years. And my impression was that he has got very little faith or confidence in Indian science and technology. And I was convinced about it. Till the Operation Sindoor. You see a sea change in his attitude towards engineering, towards scientists after this operation. Why? Because, you know, when we are talking of war of today is not man to man. It's not like what used to happen 50 years back or 100 years back, not like World War I or World War II. Today's war is actually more and more non-contact war. When you say more and more non-contact means what? That means it is the technology that is fighting the war. And if technology fighting, who is the responsible for technology? The engineers. And first time probably he realized, if you really see Operation Sindoor and analyze that, I did one exercise. There are at least 15 different technologies. They have been used in those 2 days, and they have made all the difference. But I was giving a talk in NIAS once, just about 2 months back, trying to see who are the people. And you will be surprised. I'll just give 1 or 2 examples to you. See, when we talk of BrahMos, where from BrahMos came? It was one person's thought. He thought that if we can combine with Russia, because he used to be often going for Russia for different purposes, then we can make this missile together, because we have all of the technology except we didn't have the so-called hypersonic engine. So he proposed that and joined with Russians. So it's called actually BrahMos, I think, our 2 rivers. One is Moscow River, another is our Brahmaputra. BrahMos comes from that. So there's one person behind it. I won't name right now. There's another person who has spent a lifetime only on Akash. Actually, he started work in late 70s and retired. And actually, the result has come only after so many years. Akash made a hell of a difference. There is one person, again, and I can be open here, which has not been publicized much. He has such a huge capability. All of you have got a telephone, mobile today. He can make you feel, if you go to Google, as if you are sitting in Delhi. All of you will see the mobile and will see this is Delhi. He has that capability. Now you imagine if a missile is coming and you can fool a missile that, okay, rather than coming to Delhi, and he makes it appear as some other village 10 kilometers, the missile is useless. So such technologies have been used for the first time in the world, some of them. And that's why the Operation Sindoor was so successful. And this is first time probably, I feel so, that our Prime Minister realized that, look, engineers or scientists are important. Now this realization, actually we should capitalize. And also, we should also see that, okay, one is, of course, it gives us, all of engineers, pride that, look, we have been useful to this country, even in terms of war. Of course, we have been useful in terms of food, we have been useful in terms of the IT, all that is known. But even in the war, we can make such a difference. So this, why I'm giving this thought is that engineers have to have a role which is quite different than, and particularly INE is very different today than any of our such associations, such academies. And my wish as a past president is that particular exercise, that particular relevance to the country, that particular thinking that yes, we will solve the problems of the country before they appear. With that message, I feel that this is the message has to go to all younger people, all students, and all of us. With that, I'd like to close my thoughts to you. Please continue to thought that you are important for the nation. Thank you.
Thank you, sir. Moving forward, we now begin the felicitation ceremony. I would like to invite Dr. P.S. Goel to kindly felicitate Professor Aditya K. Jagannatham, coordinator of Theme 1. May I now request Dr. Goel to felicitate Professor Santanu Chaudhary, Vice President INE and Coordinator of Theme 2. I would now request Goel sir again to kindly felicitate Professor Nishchal Verma, convener of the Engineers Conclave 2025. Thank you, sir. Ladies and gentlemen, thank you, sir, once again. Expressing gratitude reflects the noblest character and aspect of our culture. On this note of thankfulness, may I request Professor Nishchal Verma to kindly propose the vote of thanks, acknowledging everyone who contributed to the success of this conclave.
Thank you. Distinguished dignitaries on and off the dais, esteemed guests, faculty colleagues, industry leaders, research professionals, participants, volunteers, students, fellow engineers, and ladies and gentlemen. As the convener of the Engineers Conclave 2025, hosted this year by the Indian Institute of Technology, Kanpur, in collaboration with Indian National Academy of Engineers, INAE, it is my singular honor and privilege to deliver vote of thanks at the conclusion of this remarkable gathering. We are deeply grateful to Dr. Somanath, who is present here, our esteemed chief guest, for gracing the conclave with his presence and insights. Thank you, sir. I extend heartfelt thanks to Professor Manindra Agrawal, our director of IIT Kanpur, and Mr. J.D. Patil, President of INAE, for serving as co-chairs and guiding the event with their leadership. Thank you, sir. A special note of appreciation to my colleagues at IIT Kanpur, Professor Jitendra Bera, Dean of Faculty Affairs, IIT Kanpur, and Professor Yogesh Chauhan, Head of the Department of Electrical Engineering at IIT Kanpur, for their overall coordination. I also thank the advisory constituting Professor Jayant Singh, Professor Khantesh Balani, Professor Siddharth Panda, and Professor Y.M. Joshi for their all possible support. I would also like to thank our organizing team members, Professor Jalil Akhtar, Professor Aditya K. Jagannatham, Professor Kantesh Balani, Professor Raghavendra Chaudhary, Professor Nagarjuna Nallam, Professor Abhilash Patel, and Professor Mohit Ganeriwala for their tireless efforts and valuable contributions. I now request Mr. J.D. Patil, President INAE, to kindly felicitate our organizing team for playing a key role in organizing the event. I would now invite Professor Jalil Akhtar to please come on stage. Professor Raghavendra Chaudhary, Professor Nagarjuna Nallam, Professor Nagarjuna, Professor Abhilash, Professor Abhilash Patel, please come on stage. Professor Mohit Ganeriwala, please come on stage. Thank you. Thank you. Thank you. I would also like to thank Mr. Vijay Shukla and his entire team from Electrical Engineering Office for their help. The academic environment, administrative support, and impeccable arrangements at IIT Kanpur provided an inspiring backdrop for this year's event.
The energy, enthusiasm, and commitment of our faculty colleagues, staff, research scholars, and student volunteers have been truly commendable. A heartfelt shout out to volunteers, Abhisha, Ruby, Aditi, Shubham, Saurabh, Tilak Dhari, Dr. Anubhav, Prakriti, Ashlesha, Anusuya, Shreya, Akshay, Akif, Sanbor, Arif, Vikas, Pooja, Dr. Sanjeev, Insha, Neelam, Lisa, Atino, Pradeep, Ritik, Aman, Aditya, Ishan, Dhananjay, Pradeep, and Harsh for overseeing overall arrangements. We extend sincere thanks to our sponsors and industry partners, Keysight, Agmotel, and IEEE UP section for their generous support and collaboration. IEEE UP section chairperson, Professor Yogesh Chauhan is present over here. Your contributions enabled the seamless execution of this event and reinforced the essential synergy between academia, research, and industry, the cornerstone of innovation-led growth. Our deepest appreciation to the theme coordinators, Professor Shantanu Chaudhary, Vice President INAE, Professor Aditya Jagannatham, and Professor Jalil Akhtar, for curating expert panels and facilitating insightful deliberations. I also thank Dr. Mishra and Dr. Goel, former presidents of INAE, for chairing the plenary sessions, along with the esteemed session chairs and distinguished speakers across 4 panel sessions for their thought-provoking contributions. Thank you, sir. We are grateful to the INAE leadership, President, Vice President, Council members, and fellows for their unwavering guidance and vision. Your commitment to advancing engineering excellence continues to inspire us all. A special word of thanks to the INAE organizing team, Colonel Rai. Can you please stand up? Thank you. Ms. Pratigya Laur, Colonel Sharma, Dr. Chanchal Moni, Mr. Seetal Sharma, Mr. Rakesh, Mr. Piyush, and all those who were working behind the scenes. Your meticulous planning and seamless coordination were the backbones of this successful event. Finally, to all the delegates, participants who joined us from across the country and abroad, thank you for your active engagement and meaningful contributions. Your presence transformed this conclave into a vibrant celebrations of engineering excellence and collaboration. As we conclude Engineers Conclave 2025, let us carry forward the ideas, partnerships, and inspiration it has generated. May we continue to work together towards innovation, sustainability, and societal progress through engineering. So with these words, now the Engineers Conclave 2025 is being declared as closed. And let us join for the tea in the outreach now. Thank you very much. Thank you. So I would like everyone to please join us for the group photograph.
Thank you all. Request to stay back for the photograph. And our sincere thanks to the convener of the conclave, Dr. Professor Nishchal Verma, please. Thank you very much, sir. आइए सर ऊपर सीनियर्स प्लीज बाहर बच्चों का करवाते हैं सर आप सीनियर लोग प्लीज आ जाइए बच्चों के साथ हम बाहर करवाते हैं एक बारी आइए सर प्लीज डॉक्टर सोमनाथ सर मे आई रिक्वेस्ट सर डॉक्टर सोमनाथ सर लुकिंग सर कहाँ आगे सर अच्छा आगे and meanwhile I'll request the kids to assemble right outside. We'll have a quick group photograph before we disperse. Sir, please come. Please come. All the honorable speakers, senior faculty members, kindly come on the stage for a group photograph. And then I'll request the volunteers also to kindly come to the dais. All the volunteers, please. Sir. Sir.